Okay, welcome back. Now that we built a number of pipelines and data flows in ADF, it's time to put them all together so that they process the data without any manual intervention. In this lesson, we'll first try and understand our requirements for orchestration, and next, we'll assess the capabilities within Data Factory to achieve this, and finally, we'll set out the goal for the forthcoming lessons in this module. Let's get started with the requirements. Firstly, we want our pipeline executions to be fully automated. We do not want to be manually triggering the pipelines like we did during development. Second, we want our pipelines to be running at regular intervals at which we expect the new data to arrive, or when an event has occurred, for example, a new file has arrived for us. Next, we want our activities to execute only when the upstream dependency has been satisfied. For example, we want the transformation activity to execute only when the copy activity to ingest the data has succeeded. Finally, we want the solution to be easy to monitor for progress, and also we want to be able to resolve any issues with ease. These are our requirements. Now let's have a look at the options available for us within Data Factory to achieve this. Data Factory allows us to chain the activities together and execute an activity based on the success, failure, or completion, i.e. status of the previous activity. We implemented this in some of our pipelines already. In a similar manner, Data Factory allows us to chain the pipelines together within the parent pipeline. We can then execute a pipeline based on the status of the previous pipeline. We haven't done this. What we'll do is we'll implement this for one of our pipelines in the next lesson. Data Factory also allows us to create dependencies for event triggers, but there is only support for currently tumbling window triggers. There is no support for this in event-based or schedule triggers, so you cannot make an event-based trigger to wait for a file to arrive as well as dependent on another trigger to follow. So we've already had some lessons on event-based triggers and schedule triggers, but not on tumbling window triggers. So I'd like to use this opportunity to implement this for one of our requirements in the following lesson. Finally, you can create custom-made solution to execute pipelines from different SDKs such as PowerShell, .NET, Python, or REST API. I would only recommend using these when you have exhausted all the other three options listed here. This is because you incur additional cost to create and maintain these custom-made solutions, and also they're not obvious for anyone new joining a team because they're not available even within the Data Factory. They're sitting outside of the Data Factory. So I hope this has given you the options available for you. Let's now switch over to Data Factory and discuss the solutions we're going to use for each of our pipelines. Okay, here we are in the Data Factory. Now we've got 9 pipelines, 16 datasets, and 2 data flows. What I suggest doing is actually group these pipelines into appropriate groups so that we can talk about them in a meaningful way. So as you can see here, we've got 2 pipelines for ingestion and another 4 for processing data, which is transforming data, and then we've got 3 for the SQLize. So I'm going to create folders. When you have a big project, it'll be good to do it this way so that they are grouped together and it's easier for people to find when they need to find them. So I'm going to call the second one as process, and let's call the third one as SQLize. And now what you can do is you can drag the ones you want to into the appropriate groups. Let's do the same thing for the datasets. We got some lookup, raw datasets, and then you got processed, and then you got SQL datasets. So let's do that. I'm going to create a new folder for raw, and then I'm going to create one for processed, and I'm going to create one for the SQL, and also I need one for the lookup. Let's move the objects accordingly. Okay, we've done everything, and data flows we only have 2, and both are just transformations. So that's okay. We can leave the data flows as they are, but as you can see here, we've nicely grouped everything together, and it's easy to talk about them now. So, as we know, we've got ingestion for the population data that is based on an event-based trigger. So when the file arrives in a storage account, we pick the file, put it into our data lake, and then we process that data through our transformations. So this is being transformed by the Databricks notebook, and that data is used for data science purposes. That doesn't get SQLized. And the other set of data we got is the ingestion from ECDC website, and then out of those, we process all of the data, put it into our data lake, and transform the data as well. And we only copy the cases and deaths, hospitalization and testing data across to our SQL database. So we can clearly see we got 2 sets of processes, one for the ECDC data, one for the population data. And this one is based on the event, and this one is we go and grab the data, what's available on the ECDC website on a specific day. And we want to run this one every day. So what I propose doing is we use the option of creating a parent pipeline and tying this ingestion pipeline and the process pipeline into that pipeline as a solution for orchestration for the population data. And for the ECDC data, we got a number of those, so we'll use a tumbling window trigger for that one. So in the next lesson, we'll look at doing the parent pipeline for this population data pipeline, and we'll create a corresponding trigger as well. And in the following one, we'll look at the ECDC data. But before we finish, let's publish our changes to the Data Factory so that they're saved. And I'll see you in the next lesson. Okay, welcome back. In this lesson, we're going to create a parent pipeline which will execute the ingestion and transformation pipelines one after the other for the population data. We'll then create the trigger to execute the pipeline as soon as the file arrives in our Azure storage account. Let's switch over to the Data Factory and get started. Okay, here we are in the Data Factory. So let's look at the pipelines first before we go ahead and create the parent pipeline. So this is our ingest population data. As we know, actually, it checks for the file. If it's there, then it processes the file through. And basically, it takes the file from the Azure storage account into the data lake storage. And once the file is there, this process here takes the file, executes the notebook in Databricks, and transforms the data to our needs and puts it back into the process container in our data lake. So what we want to do is we want to execute the process population data after the ingestion population data. So we could do one thing, which is not to have 2 pipelines. Instead, we can take that activity and stick it at the end of this activity. So the activity for the notebook will only execute once this is succeeded. So that is one option. We didn't do it in the first place. That's mainly because we wanted to be able to execute the ingestion separately from the transformation. That is a good idea. So you've got a level of control on what you are rerunning when you come to rerun a pipeline. So let's assume we're not doing that. We are going to keep 2 pipelines, and now we're going to create a parent pipeline which will execute that first, and then based on the status of that, the other pipeline will execute. So let's create a folder first because we've got some good practices here. Let's continue that. So that'll be called execute here. So any kind of execution pipelines would go here. And I'm going to create a new pipeline, and I'm going to call that as PL execute population pipelines. In order to execute the other pipelines, Data Factory gives you an activity which is called execute pipeline. So you can just execute a pipeline by calling this activity. So I'm going to call this one as execute ingest population data. And let's get to the settings. It's quite simple. There isn't an awful lot of options. So invoke pipeline, we need to pick that one, which is the PL ingest population data. And we want to wait for the completion of this one before invoking the next one. So let's tick the wait on completion box, and there are no user properties here. So that's pretty much it. So this pipeline now will execute the other pipeline, and we want to do one more execution. So let's bring in the execute pipeline activity again. And this time, this is to execute the process population data. So let's get to the settings and then pick that one. So that will be the PL process population data. And now we need to link the two. So if you look at the green box here, just pull that over into the execute pipeline. This is very similar to how we link two activities, i.e. making one dependent on the other. So in this case, we are going to invoke the process population data on success of the ingest population data. But if you wanted to invoke a pipeline based on a failure or other conditions, you can just click on the plus here, and then that'll give you other conditions. So the green one is success, which is the default normally, and you can have a failure pipeline, and then on completion will be whether it's a success or a failure, it's going to go through to that pipeline, or it's skipped. So when you're skipping a pipeline, you could just get to the next one. So you got all these options here. So with that, we finished creating our pipeline. The next thing we want to do is we want to have a trigger. So we already had a trigger for our ingest population data. So we got a trigger attached to that one. Let's have a look at that one. So that is the TR ingest population data. And that was going to execute when the file arrives in our population folder within our RSU storage account. So we need the exact same trigger, but not on this one now. We want to have that on the parent pipeline. So let's remove this trigger. I'm going to go back again, and you can just click on that just to remove it and close that trigger. And let's go to the triggers tab. I'm going to create a new one because we could reuse this one, but Data Factory doesn't let you rename a trigger, unfortunately. So what we'll do is we'll create a new trigger and then we'll delete this one afterwards. So let's do click new. I'm going to call this one as TR underscore population data arrives. That is the event, right? Okay, we want to pick the event trigger because that's what we want, and we want to pick the storage account from where we want to check for the event to happen. So that's in my PaySeGo subscription, and the storage account is the COVID reporting SA storage account, and the container name, we should be able to pick it up from here. That is the population, and the block path is population by age.tsv.gzip file. And we want the trigger to trigger on the event of the blob being created. And we can ignore empty blobs. We want to have some data, and we can click activate it as well. And click continue, click OK. And now the trigger is created as well. Now the next thing to do is we want to delete the other trigger, which we don't need, so which is the TR ingest population data. So let's do that. So that's disappeared. So we got this trigger, and let's go to the pipeline and then attach the trigger. So this is our parent pipeline. So that is this one, PL execute population data. And I'm going to add the trigger here. So that'll be new edit, and then we pick the trigger, so which is the TR population data arrived. And it's exactly what we specified in the while creating the trigger. And let's click continue. And that's the same warning, so we can ignore that and click continue. And the pipeline doesn't have any parameters, we know that. And we need to publish the trigger to be activated. Publish for the trigger to be activated. So let's click OK. And if we do a publish all, the trigger will be active. So let's click publish again. And the publishing is completed now. And let's go back to the trigger. So the trigger is started. It's basically running, waiting for the file to arrive. So the next thing what we'll do is we'll put the file into our storage account and see whether the trigger executes. So let's go to the Storage Explorer. And this time we want to go into our standard storage account, which is the COVID reporting SA. And let's get to the population container. And we want to put the file here. So let me upload the file. And that would be one folder under data. And I've got a folder called population. And this is the file, the tsv.gzip. It's waiting for, so click open and click upload. Okay, so the file is now uploaded. Let's switch back to the Data Factory and see whether the trigger is running now. So yes, it is running. So as you can see, we got two pipelines running, which is the parent pipeline, which has invoked the ingest pipeline. So let's get to the trigger runs. It's easier to do it from here. So as you can see, the TR population data arrive trigger is the one we just invoked, blob events trigger. And let's click on the pipelines. This is the easiest way to browse through to the pipelines and then click on the pipeline. So that'll take you to the parent pipeline. As you can see, the ingest population data has already finished, but the process is running now. So you can see clearly here. And let's do a refresh. Okay, so let's click on the status of this one. So if I click on that, that'll take you into the PL process population data, and that's executing the notebook. And if you look here, that will be provisioning the database cluster at the moment. So let's have a quick look. Okay, yes, it is waiting for the cluster. As you know, it takes normally about 3 to 4 minutes to provision a database job cluster. So let's wait for that, and then we'll come back to the pipeline and see whether that's finished. Okay, so the execution is now completed. It took about 4 minutes to process that data, so which is great. Let's go back and understand what's happened very quickly one more time. So we created this trigger, TR population data arrived, which executed our pipeline, which is the PL execute population pipeline, which in turn executed the ingest and the processed one after the other. So if you go into monitor, now you can see trigger runs because this is a trigger that executed and TR population data arrived, and then you can click from here to get to the parent pipeline, or if you want to see all the pipelines that executed, you can see here as well. So I normally like to go from here, so that is our trigger that executed just now, and I go into this one, so that tells you both pipelines that is executed, and then from here, whichever one you want to go to, you can just click through those. So this is an approach you can use to chain your pipelines together and execute in this manner. So that's the end of this lesson. I'll see you in the next one.
కొత్తగూడెం జిల్లా.
Okay, welcome back. In this lesson, we're going to create tumbling window triggers to execute the pipelines, and also we'll create dependencies between them. You may remember from our triggers lesson that tumbling window triggers are mainly used in cases where we're dealing with slices of data. In this example, we don't have slices of data because ACDC exposes all of the data at once, but we'll still make use of it to exploit the benefits of being able to create dependencies between triggers. So let's switch over to the Data Factory, and I'll show you how that's done. Okay, here we are in the Data Factory. Let's try and understand the pipelines we got here before we try and create the triggers. So we dealt with the population pipelines in the last lesson, so we want to deal with the ECDC data in this lesson. So for ECDC, we got this ingestion data, which copies all the files we need from ECDC website into our data lake. And then we process them using separate pipelines. So we got the case and deaths, hospital admissions, and testing. Within the process, we got the transformation here, and then we got the sequelize here. So we got 7 different pipelines. So what we can do is we can create a trigger to process the ingestion of the ECDC data first. And then we can create 3 separate triggers for the process and then make them all dependent on the ingestion trigger. So they follow the ingestion. And then we can create 3 separate triggers for the sequelize. And these 3 could be dependent on the corresponding transformation pipeline triggers. So that's what we can do. We don't need to do all of them. It'll be overkill in this lesson. And also, if you remember, we deleted the HD Insight cluster which processed the testing data so that we're not unnecessarily spending money. So let's exclude that one. So we can create 5 triggers. We can create 1 for this and 2 for the hospital admissions and cases and 2 for the sequelize. If you want to do the HD Insight one and if you still have the cluster running, feel free to include that as well actually. So that means you'll create 2 separate triggers here. So let's start doing that. I'm going to do the first one for the ingestion of the ECDC data. Let's switch to the Manage tab and create the trigger. So if you remember, we got the ingest ECDC data trigger already here, which was a schedule trigger that we created early in one of our modules. So let's delete that one. We don't need it because we're going to create a tumbling window trigger for that. So let's do that. And we need to publish it because otherwise Data Factory wouldn't let you create another one with the same name. So I'm going to create a trigger with the same name, and that's going to be called TR ingest ECDC data. But this is going to be a tumbling window trigger rather than a schedule trigger. So let's get the start date. Let's do yesterday's date. And I'm going to start at midnight. So the idea is that it's going to run every day at midnight, and then each of the other triggers will follow this one. So that's going to be at midnight. So it's going to run every day at midnight. So we've got to change it to 24 hours so that it runs every 24 hours, which is daily. We don't need to do anything in the advanced. We need to do that for the other triggers, but not for this one. Let's click activate as well. So let's create the next trigger that is going to be for the process cases and deaths. So I'm going to call that one as TR process cases and deaths data. And this is going to be a tumbling window trigger. Again, it will start from yesterday at midnight, and it'll run every 24 hours as well. But the difference here is we're going to make this one dependent on the previous one. So if you click on it once and then you can click new on the add dependencies, and then you can pick the TR ingest ECDC data. We don't need to set any offsets. I'll walk you through how these ones works at the end of this lesson. But at the moment, we want this to be dependent, this new trigger to be dependent on the ingestion trigger running at the same time. So today's trigger has to be dependent on today's ingestion trigger. So we don't need any delays. I may as well just explain. If you want to run your Popper trigger at 8 o'clock every day rather than the midnight, you can start the trigger to come in at midnight. But then if you put 8 hours, it'll run at 8 o'clock. But for us, actually, we can run it at midnight and get the files from ECDC. And let's click activate, and that's done. So let's do the next process as well, which is going to be the process hospital admissions data. Okay, so we've created the 2 transformation triggers and made them both dependent on the ingestion trigger. Now we need to do the sequelize triggers. So I'm going to do the one for the process cases and sequelize cases and deaths data. So that would be TR sequelize cases and deaths data. And let's make it run at midnight as well on yesterday's date. And make it run every 24 hours, similar to what we did on the others. And now
Kowe memang aku.
you're going to make this dependent on the process cases and deaths trigger. And we just need to activate that. That's okay, done. And let's make it run at midnight as well on yesterday's date. And make it run every 24 hours, similar to what we did on the others. And now we're going to make this dependent on the process cases and deaths trigger. And we just need to activate that. That's okay, done. And let's create the new one for the hospital admission sequelize as well. Okay, I've created the other trigger as well. So we got the 5 triggers we talked about. Now we haven't started this one, so let's click on start, and this one as well. Okay, they were not started because actually I didn't click on the activated yes, I left them as activated no. So that's done now. And let's switch to the pipelines and attach the pipelines to the triggers. So this is the ingest ECDC data. Let's add the trigger, and that'll be the TR ECDC ingest data. So that's exactly what we created there. And then click OK, and click OK. So what it says is make sure to publish for the trigger to be activated after clicking OK. So we just need to publish the trigger before it can be activated. And let's do the other 4 triggers as well in the same way. Let's attach them. Okay, I've attached the other 4 pipelines to the triggers as well. And let's click on publish now, and it's got the 5 new triggers created. So let's just click publish, and it should publish the triggers, and the pipelines will be running as well. Okay, let's now switch to monitor, and then we can have a look at what's happening. So as we can see, the ingestions finished very quickly, so that didn't take much time. That's taken all the data from ECDC and put it into our data lake. And the process, both of the processes are running, and the sequelizers are waiting for the process. So let's have a look. As you can see here, this tells you the sequelizer is now waiting for the process during this tumbling window period. So as you know, process takes a bit longer because we got the Databricks cluster to spin up. That'll take about 5 minutes or so. So we'll come back and have a look at that in a bit. Okay, it took a few more minutes, and now as you can see, all the triggers are finished. So we got the ingest ECDC data, sequelize for both of them, hospital admissions and the cases and deaths, and the 2 processes are finished as well. What you can do is you can look at the window start time. So the one we started was from last night, so we got the window start time, and let's put the window end time as well. So as you can see here, this is the one from 25th to 26th. So if I come back and look tomorrow after midnight, I'll have the slice from 26 to 27. So it'll run every morning at midnight, and it'll process the data and the dependencies as we specified. I hope that's given you an understanding of how the tumbling window triggers can be used to create dependencies. Before we finish, I would like to walk you through a couple of options within the tumbling window trigger that we discussed previously. So let's get back to the triggers tab, and then you can pick the process cases and depth. And here we gave the dependency as the ingest ECDC data, but we left the offset as 0 and window size as 0. So the offset and the window size basically lets you choose which window you want the trigger to be dependent on. In this case, we wanted our trigger to process the cases and depth data for today to be dependent on today's ingestion data. So we didn't want to do any offset. But for example, you may want to process yesterday's data today and today's data tomorrow. So you ingest the data yesterday throughout the day, and then you might want to pick the data at midnight on the following day. In that case, you would specify the offset as -1. So there is a documentation within Microsoft site with a couple of diagrams that might be easier to understand. So this was our example. So we wanted our current slice to be dependent on the other trigger's current slice. So this is based on hours, but in our case, it was based on days. So the 10 to 11 slice on the trigger A is dependent on the 10 to 11 slice on trigger B. But for example, you wanted all of this data to come through, and then you start processing that in this slice. As an example here, at trigger A's 10 to 11 to be dependent on trigger B's 9 to 10, you would create a dependency between them two, but you set the offset to be -1 hour. But in our case, if we wanted 1 day's delay, then we would set that to -1 day. Similarly, you can say in my trigger, I want the 10 to 11 slice to be dependent on both 9 to 10 and 10 to 11 data to be available. In that case, you specify the offset to be -1 hour and the size to be for the ingestion of the ECDC data. Let's switch to the Manage tab and create the trigger. So if you remember, we got the ingest ECDC data trigger already here, which was a schedule trigger that we created early in one of our modules. So let's delete that one. We don't need it because we're going to create a tumbling window trigger for that. So let's do that, and we need to publish it because otherwise Data Factory wouldn't let you create another one with the same name. So I'm going to create a trigger with the same name, and that's going to be called tr ingest ECDC data. But this is going to be a tumbling window trigger rather than a schedule trigger. So let's get the start date. Let's do yesterday's date, and I'm going to start at midnight. So the idea is that it's going to run every day at midnight, and then each of the other triggers will follow this one. So that's going to be at midnight. So it's going to run every day at midnight. So we got to change it to 24 hours so that it runs every 24 hours, which is daily. We don't need to do anything in the advanced. We need to do that for the other triggers, but not for this one. Let's click activate as well. So let's create the next trigger that is going to be for the process cases and debts. So I'm going to call that one as tr process cases and debts data. And this is going to be a tumbling window trigger. Again, it will start from yesterday at midnight, and it'll run every 24 hours as well. But the difference here is we're going to make this one dependent on the previous one. So if you click on it once, and then you can click new on the add dependencies, and then you can pick the tr ingest ECDC data. We don't need to set any offsets. I'll walk you through how these ones works at the end of this lesson. But at the moment, we want this to be dependent. This new trigger to be dependent on the ingestion trigger running at the same time. So today's trigger has to be dependent on today's ingestion trigger. So we don't need any delays. I may as well just explain. If you want to run your Puppet trigger at 8 o'clock every day rather than the midnight, you can start the trigger to come in at midnight. But then if you put 8 hours, it'll run at 8 o'clock. But for us, actually, we can run it at midnight and get the files from ECDC. And let's click activate, and that's done. So let's do the next process as well, which is going to be the process hospital admissions data. Okay, so we've created the two transformation triggers and made them both dependent on the ingestion trigger. Now we need to do the sequelize triggers. So I'm going to do the one for the process cases and sequelize cases and test data. So that would be tr sequelize cases and test data. And let's make it run at midnight as well on yesterday's date. And make it run every 24 hours, similar to what we did on the others. And now we're going to make this dependent on the process cases and deaths trigger. And we just need to activate that. That's okay, done. And let's create the new one for the hospital admission sequelize as well. Okay, I've created the other trigger as well. So we got the 5 triggers we talked about. Now we have been started this one, so let's click on start, and this one as well. Okay, they were not started because actually I didn't click on the activated yes, I left them as activated no. So that's done now. And let's switch to the pipelines and attach the pipelines to the triggers. So this is the ingest ECDC data. Let's add the trigger, and that'll be the tr ECDC ingest data. So that's exactly what we created there. And then click OK, and click OK. So what it says is make sure to publish for the trigger to be activated after clicking OK. So we just need to publish the trigger before it can be activated. And let's do the other 4 triggers as well in the same way. Let's attach them. Okay, I've attached the other 4 pipelines to the triggers as well. And let's click on publish now, and it's got the 5 new triggers created. So let's just click publish, and it should publish the triggers, and the pipelines will be running as well. Okay, let's now switch to monitor, and then we can have a look at what's happening. So as we can see, the ingestions finished very quickly, so that didn't take much time. That's taken all the data from ECDC and put it into our data lake. And the process, both of the processes are running, and the sequelizers are waiting for the process. So let's have a look. As you can see here, this tells you the sequelizer is now waiting for the process during this tumbling window period. So as you know, process takes a bit longer because we got the database clusters to spin up. That'll take about 5 minutes or so. So we'll come back and have a look at that in a bit. Okay, it took a few more minutes, and now as you can see, all the triggers are finished. So we got the ingest ECDC data, sequelize for both of them, hospital admissions and the cases and deaths, and the 2 processes are finished as well. What you can do is you can look at the window start time. So the one we started was from last night, so we got the window start time, and let's put the window end time as well. So as you can see here, this is the one from 25th to 26th. So if I come back and look tomorrow after midnight, I'll have the slice from 26 to 27. So it'll run every morning at midnight, and it'll process the data and the dependencies as we specified. I hope that's given you an understanding of how the tumbling window triggers can be used to create dependencies. Before we finish, I would like to walk you through a couple of options within the tumbling window trigger that we discussed previously. So let's get back to the triggers tab, and then you can take the process cases and death. And here we gave the dependency as the ingest ECDC data, but we left the offset as 0 and window size as 0. So the offset and the window size basically lets you choose which window you want the trigger to be dependent on. In this case, we wanted our trigger to process the cases and death data for today to be dependent on today's ingestion data. So we didn't want to do any offset. But for example, you may want to process yesterday's data today and today's data tomorrow. So you ingest the data yesterday, throughout the day, and then you might want to pick the data at midnight on the following day. In that case, you would specify the offset as -1. So there is a documentation within Microsoft site with a couple of diagrams that might be easier to understand. So this was our example. So we wanted our current slice to be dependent on the other trigger's current slice. So this is based on hours, but in our case, it was based on days. So the 10 to 11 slice on the trigger A is dependent on the 10 to 11 slice on trigger B. But for example, you wanted all of this data to come through, and then you start processing that in this slice. As an example here, trigger A is 10 to 11 to be dependent on trigger B's 9 to 10. You would create a dependency between them two, but you set the offset to be -1 hour. But in our case, if we wanted 1 day's delay, then we would set that to -1 day. Similarly, you can say in my trigger, I want the 10 to 11 slice to be dependent on both 9 to 10 and 10 to 11 data to be available. In that case, you specify the offset to be -1 hour and the size to be 2 hours. So that means it's waiting for 2 slices. So if I switch back to our example, if you wanted the process to be dependent on ingest for 1 day in earlier, so you would say -1 here. And if you wanted 2 of the days to be dependent on that one, then you would specify 2 days there. So that's the meaning of offset and window size here. And I think we talked about all of these previously. So that's the end of this lesson, and I'll see you in the next one. Welcome to a new module on Azure Data Factory Monitoring. Now that we've completed building our project, in this module, we'll have a look at the options for monitoring and implement them for our application. First, we'll start with looking at what needs monitoring. We'll then look at how to use monitoring capability built into the Data Factory toolset. That'll be followed by creating alerts, recovering failed pipelines, and reporting on metrics. I'll then give you an introduction to the Azure Monitor. We'll then explore the capabilities of Azure Monitor and how we can monitor multiple data factories from one dashboard. We'll finish the module by deploying the Azure Marketplace solution called Azure Data Factory Analytics. I'll also show you how to extend that solution. There is a lot to cover, so let's start with identifying what to monitor and the options available in the next lesson. I'll see you then. Okay, welcome back. Now that we've engineered our data pipeline from end to end, let's look into how we monitor these pipelines. As part of monitoring, we want to ensure that the pipelines are up and running and in a healthy state, so that our data scientists and the analysts have the data they need to carry out their job. First, let's look at the things we would like to monitor. Azure Data Factory, as you know, is a managed service, and it runs on a serverless architecture, so we don't have an awful lot to monitor there. We might want to monitor only simple things like size of our data factory or the total number of objects we created, etc. Next, we would want to know about the status of our integration runtime, for example, the CPU utilization and the available memory in the integration runtime, etc. Next, we would want to know the status of our trigger runs, have the triggers been run, whether they succeeded or failed, etc., so that we can go in and fix any issues. And we would also want to know similar information about our pipeline runs and activity runs. In order to do this, we have 2 options available. The first one is the monitoring capability within the Data Factory itself, and I hope you guys are familiar with that by now because we have looked at it a couple of times in the past. Secondly, we have the wider Azure Monitor built into Azure for all Azure resources. Let's have a look at the capabilities of the Data Factory Monitor first. This can be used to monitor the status of pipelines, triggers, and activities within a Data Factory. We can use this to rerun any failed triggers or pipelines. We can generate alerts from base level metrics available. For example, we can trigger an email when a pipeline or a trigger fails. There are a couple of limitations with the Data Factory Monitor itself. The first one is that it only provides base level metrics and logs. And also the pipeline runs are only kept for 45 days, so you cannot look back at a pipeline that ran more than 45 days ago. Now let's have a look at the capabilities of Azure Monitor. With Azure Monitor, we get the ability to route the diagnostic data to other storage solutions, such as storage accounts, log analytics, and Event Hub. By doing this, we can keep the logs for as long as we need to, unlike in the Data Factory, where it's only kept for 45 days. Azure Monitor also provides richer diagnostic data that can be used to identify and establish the problems better. As the data is kept in other storage solutions such as log analytics, we can use custom queries to write complex logic, and also we can use other reporting tools such as Power BI to report our data better, and also in a meaningful way which is relevant for our requirements. Data Factory monitoring only allows us to monitor one data factory at a time, whereas Azure Monitor allows us to monitor across multiple data factories, which is fundamental and which is key for large organizations. Because you wouldn't want to be reporting from one data factory at a time. In that case, you'll have to go into each of the data factory to look at what's happened. Whereas you can have one big dashboard which will report across all your data factories. I hope this introduction has given you an idea of what we can do in terms of monitoring within Azure for our data factory pipelines. In the next lesson, we'll look at how to monitor our pipelines and triggers within the data factory monitoring, and in the following lesson, we'll tackle the Azure Monitor. I'll see you then. Okay, welcome back. In this lesson, we're going to look at the capabilities of Data Factory Monitor. We'll look at the status of triggers and pipelines within our data factory. We'll look at rerunning a failed pipeline, and we'll look at the metrics available and how to add them to our dashboards, and also we'll create alerts from failures in our pipelines. So let's switch over to the data factory and get started. Okay, here we are in our data factory. Let's switch to our monitor tab, and you've got these options on the left in your monitor. So the first one is dashboard. That's what you're seeing here. These are pre-canned dashboards for you. So you've got the pipelines, triggers, and activity runs here. So the default is 24 hours, so you've got the last 24 hours where the pipelines, triggers, and activities are listed here. I've got 5 pipelines and 5 triggers running, and they in turn invoke a couple of activities each, so that's why you've got the 10. I don't have any failures at the moment, but we will mimic failure, and then we'll look at that again. So the filters you've got the time, which is the reporting time for this dashboard, and it's currently reporting the last 24 hours. But if you wanted to pick the last 7 days or 30 days, you can pick them. So this is the last 7 days. And if you want to go over a custom period, then you would go for a custom period by specifying the time. And you've got time zone support here, and quite a few time zones. So you pick your time zone where you've got your triggers or pipelines running as well. So that is the dashboard. It's very simple. You can't really tweak anything, so you can't add to this dashboard, but I'll show you how to create your own dashboards later. And these two, you've seen them before, but I'll quickly go through those ones. So you've got the pipeline runs and the trigger runs. Let's start with the trigger runs. So it's currently showing the last 7 days because we set the filter on the dashboards, but we can turn it into last 24 hours. So the filter is exactly the same as the other one we've seen. So if you want to do a custom date, you would do the custom date range, and then you can specify the time zone as well. So let me go back to 24 hours. So we're seeing fewer triggers. So as we saw in the dashboard, we got these 5 triggers running every day for me at the moment. And you can do filters on your trigger name, so you can filter on the trigger name. If you have many, that'll be really handy. And you can look at the status as well. So if you want to look at all the failed ones in the morning, so you would come in and then just filter on the failed, and you can fix them. So the other thing you've got is the latest runs and the all runs. So if you had a failure and then if you rerun that one, normally it shows you the latest run by default, but if you want to see the previous runs, then you click on the all runs and then you can do that. I think I did one of those in the last few days, so let's see whether we can find that. As you can see here, the trigger on the 26th, I ran it twice, so you've got the one here, and then you've got another one, so this one is still waiting for dependency. That's because I put that in incorrectly, so it hasn't satisfied the dependency window. So, but if you run a failed one, or if you're rerunning a trigger, you will see them here as well. So that is that. And in the pipeline runs, you'll see all the pipelines that ran. So I'm going to again filter it to just the 24 hours. So we got fewer records. So we got the 5 pipelines triggered by the 5 triggers are here. So here you will see the start and end, and then the duration, and then whatever trigger is triggered. So you'll see any parameters. We don't have any parameters on those ones. And if you put any annotations, you can see them as well. If there are errors, you'll see them. And you can add further filters as well. So you've got the filters on pipeline name, status, and runs. And you can add annotations, a filter on the annotation, for example. So that is what you do there. And again, the filter here is the custom time range and the 24 hours and 7 days and 30 days. So that is the pipeline runs window. So next we got the integration runtimes. So we can report on the status of the integration runtimes from here. At the moment we only have the default auto is all integration runtime, but if you had any self-hosted or Azure SSIS integration runtimes, you would see all of them listed here with their statuses. And if you had a data flow in debug mode, then you would have those data flows listed here, so you can come and monitor those here as well. And the other thing, this is quite important, so you can create notifications from the Data Factory monitor. So if, for example, you want to report on any failures or successes of triggers or activities or pipelines, you could come in here and create a new alert. So you set your target criteria and tell Azure what to do, whether it's an email or send an SMS or a voice notification, for example. And we'll do this in one of the forthcoming lessons. And also, you can report on the metrics, but if you click on that one, that opens up Azure Monitor, and you can create metrics from here. So you'll select your Azure Data Factory, and then you can report from there. So I'll show you this in one of the forthcoming lessons as well. So that's the end of this lesson. In the next one, we will try and create a failure, and then we'll monitor that within our dashboards. And I'll show you how to rerun from a failure as well. See you then. Okay, welcome back. In this lesson, we're going to look at alerts. We can use alerts to inform about any kind of activity within our Data Factory. So for example, we would want to know about any failures within our pipelines or triggers or... Okay, welcome back. In this lesson, we're going to look at alerts. We can use alerts to inform about any kind of activity within our Data Factory. So for example, we would want to know about any failures within our pipelines or triggers or activities. Or even some cases we might want to know a pipeline has succeeded as well. So in order to establish those, we can create alerts. So you come into the Data Factory Monitor tab and then click on Alerts and Metrics and then click on New Alert Rule to create an alert. So I'm going to call my alert as AL_trigger failures because I'm going to trigger this alert when there is a failure in any of our triggers. So the next thing to do is you can set a description here. I'm going to leave that as blank, and then you want to specify the severity of this alert. In my case, I'm going to set it to 0 because I think it's a high severity when there is a trigger failure because we don't have data for our end consumers. And once you've done that, you've got two things to do. One is to create the target criteria, and the other one is to configure the notification. So to do the target criteria, you click on Add Criteria. It lists all the metrics available within the Data Factory. So in our case, we want to pick the metric where there is a pipeline, sorry, trigger failure, so which is failed trigger runs metrics, and then you want to configure them. But if you wanted to configure others like cancelled activities or cancelled triggers, or even successful trigger runs, then you can pick any of those from here. Let's pick the one for the failed trigger runs metrics and click Continue. And it quite helpfully gives you the failed trigger runs within the last 6, 12, or 24 hours. So you can pick the right trigger from here and then configure the notification from that one. In our case, what we want to do is we want to pick the trigger which ingests the ECDC data for any failures. So let's pick that one. But if you wanted to pick all triggers, then you can do that as well. So I'm going to go for this one. And failure type, you can choose specific type of failures or any kind of failures. So I'm going to go for all failures here. So let's do that. And now we want to specify the logic. So do you want to know about every failure, or do you want to know about a failure when that's happened more than once? So in this case, we want to know about any kind of failure. So we can say if the metric value is more than 0, that is, you got the first failure itself, you want to know about it, then we can get the failure. Now you specify the window. So you've specified there that, for example, if we said actually my threshold is 1, so I don't want to know about the first failure, I want to know about everything after that. You still want to specify the window. So do you want to know about the failures within the 24 hours window, or within the last 10 minutes window, or a 1 hour window? So in this case, we're going to go for the default of 1 minute, and also we want to check every minute whether there is a failure. So that's what these two specify. So I'm going to put that back into 0. So that means we'll get every failure notified, and click on Add Criteria. So now that we've specified our target criteria, if you want to add another criteria, you can add that as well. So for example, if you wanted to monitor the pipeline runs as well, then you add another criteria. the next thing to do is to configure the notification. So click on configure notification. We need to specify the action group name and the short names. I'm going to go for COVID support project. And we need a short name as well, so I'm going to call it as COVID sub here. Now we need to add a notification, so let's click on add notification. And we want to name our action. In this case, we're going to send an email, so I'm going to call that as email send. And then we want to check the email, and you need to specify your email address. If you wanted to get SMS and or app push notifications or voice message from Microsoft, then you can tick these things as well. But in our case, we're going to keep it simple and send an email. And now click add notification. So we got the notification added, we got the action group to create. So click on the add action group. So that should create the action group. And now we got everything configured. So we got the target criteria, we got the notification set, and we can specify whether we want to enable the rule upon creation. I'm going to do that. Otherwise, you can turn it off and turn it on later on, and then click on the alert rule. So that should create the alert rule. Okay, now the alert's been created. So from now, I'm going to get an email for every trigger failure within our data factory. If you wanted to turn it off, you can click on here to turn it off, and this is to turn it on. And you can delete your alerts afterwards, or you can change the alerts as well. So that's how we create alerts within Data Factory. So that's the end of this lesson. But in the next lesson, we are going to break one of our triggers so that we get a notification into our email, and also we can come in and monitor the dashboards and rerun the failed trigger. I'll show you all of that in the next lesson. I'll see you then. Okay, welcome back. In the last lesson, we created the alert to trigger when there is a trigger failure. So let's try and break one of our pipelines, which is the ECDC ingest pipeline, so that we can see whether the trigger is firing. So let's get to our author tab, and under ingest, we got the PL ingest ECDC data. So as you can see here, this pipeline initially reads data from our config file and then processes the files accordingly. The config file tells us where to get the files from on the ECDC portal and where to put them. So if we make changes to the config file so that it is pointing to an URL which is invalid, then we'll get a failure. So let's do that. So let's switch over to the Storage Explorer, and under COVID reporting SA, we got the configs container, and that's where we got the config file. So this is the config file, ECDC file list.json, and let's open that up. And here, as we said, we got the source base URL, which is https opendata.ecdc.europa.eu. Let's change the Euro part to Europe. So let me replace, and let's do a replace all. So that's done, and let me save this file, and it should upload to the storage account as well. So let's do that. And that's now been uploaded. Let's switch back to our data factory and then get to triggers, and we got the trigger runs, and this is the TR ingest ECDC data. If we click here in this, it's going to rerun the trigger. So that's what we want to do. So we're going to rerun the trigger that ran at midnight this morning so that it fails after this. So I'm going to rerun that one. So click OK, and let's see what happens. So I'm going to refresh, and it should show us OK. So that's waiting. So that's going to go through now. As we expected, the trigger has failed, so let's see where it's failed within the trigger. You've got two options. Either you can click on number 1 here to get to the pipeline, or you can go straight to the pipeline runs. So I tend to normally do this way so that I know which trigger relates to which pipeline, so I'm going to click on number 1, and that gives you the pipeline. So as we expected, so it's done the lookup, so it's got all the information from the lookup, and it's tried to copy the data from the portal, and it would have failed with the error that actually the portal URL is invalid, so the remote name could not be resolved. So that's what it's failed with. Okay, let's see whether we received the email notification for that failure now. Okay, so we got this email here. So that was triggered by the Azure monitor, and it tells you that actually it's the alert name AL trigger failure. It doesn't give you an awful lot more information. It tells you which trigger fired that. So that is, you got the name of the trigger and then the failure type. So you won't know exactly what failure it is, but that you'll have to go into Data Factory to have a look at it. But otherwise, you got this information. So this kind of triggers the support team to come in and work on the failure. Let's now switch back to Data Factory, and I'll show you the dashboard with the failures. So we should see some failures on the pipelines, activities, and triggers. So as we're seeing, within the last 24 hours, we've had 1 trigger failure and 1 pipeline failure, and 5 failed runs on the activities, because there were 5 different failures within the activity as well. So let's now look at resolving this issue. As I said before, you can look at the pipeline issue from the pipeline runs as well. So let's get there, and then if you click on that, you'll see the failures. And we've had the 4 copy activities and the for each statement that called the copy activities have failed. So that's why you got 5 activity run failures. That's the end of this lesson. In the next lesson, we'll look at fixing the failure and rerunning the pipeline. I'll see you in the next lesson. Okay, welcome back. In this lesson, we're going to look at fixing this failure and rerunning the pipeline. So you've got a couple of options to rerun the pipeline, and I'll show you all of that. But before that, we need to fix our config file that we broke so that the failure is going to succeed. So let's get to the Storage Explorer, and this is the config that we broke. So let's open that up and make the changes we need to make it right. So we need to change the Europe to Europa. And now we need to save it and upload it to the storage account. So let's do that, click apply, and the file's being now transferred across to our storage account. So let's switch back to our Data Factory. As you can see here, you've got a couple of options. You can either rerun the pipeline from the beginning, or you can rerun from a failed activity. So in our case, we only got a lookup activity that took about 3 seconds to complete. But if you had a few activities up front which took hours to process, you don't want to be going all the way back and rerunning all of that, because it takes that long to get to this activity now. Instead, you got the option to rerun from a failed activity. At first sight, you might be thinking that rerunning from the failed activity here would resolve our issue, because we got the lookup activity that's already succeeded. So let's do that, because I want to show you how to rerun from a failed activity and what happens in that scenario. So let's do that first. So as you can see, when we rerun from the failed activity, it skips the activity that succeeded previously. So in our case, the lookup succeeded, so it didn't rerun that activity, and it jumped straight into the for each activity. But I do expect this to fail now. That's because our lookup activity, when it read the data first time, it read the URLs as Europe.eu, and they are the same information it's still keeping, because we are not rerunning our lookup activity. So we'll still get the same failure on our for each to copy the data. So as you can see here, the copy activities have failed again, even though the lookup was skipped, and that's because actually we still have the wrong URL. So we can look here, and as you can see, the report name could not be resolved. So we have got no option in this case other than to rerun the full pipeline. So you can either do it here, or you can come back and you can rerun the trigger here. So let's do this. It is the same as what you do inside the pipeline itself. I set trigger by this pipeline. So let's do that. And it's running, so let's get into the pipeline. As you can see, it's rerun the lookup and it's doing the copy activities, and I would expect them to succeed. As you can see, they are succeeding. So the pipeline's now succeeded. So if we go back into our all pipeline runs, and it shows as succeeded, and it's shown as a manual trigger because we manually invoked the pipeline in order to run it again. We didn't use the trigger to do it, so that's why it shows manual trigger and it succeeded. But one thing to know is that this is being triggered manually. So the trigger itself, which triggered this pipeline, will still show as failed, which is quite annoying because we fixed the pipeline that failed, but we got a failed trigger showing up here, which is quite annoying. Hopefully Microsoft will fix this and propagate the internal statuses back to the trigger itself at some point. But at the moment, it doesn't happen that way. But if you want to see everything has succeeded, the option you've got is to rerun the whole trigger, and it triggers the pipeline, and you've got everything succeeded again. So let's do that. So I'm rerunning the trigger, and it's waiting. It's going now, and the pipeline should be running. Yep, it's running at the moment. So let's see whether it succeeds. Okay, everything succeeded. So if we go back to the pipeline runs, you should see everything has succeeded, and the trigger should now show as succeeded as well. So a couple of things to note here is if you wanted to rerun a failed pipeline from the middle of its graph, which is from a failed activity, you can do that within the pipeline, and that'll show as manual rerun. And also, if you wanted to rerun just a pipeline without rerunning the trigger, you can do that as well. And again, that'll show as a manual rerun, and the trigger will still show as failed. But if you wanted to make the trigger succeeded, then you would have to rerun the trigger. The scenario where you would want to do this, rather than rerunning the pipelines themselves from the failed activity, is when you have another trigger which is dependent on this one. Because if you don't make this a success, then the other dependent trigger won't run. This is only a problem with the tumbling window triggers because you can't create dependencies between event triggers or schedule triggers. So when you have a tumbling window trigger which is dependent on another tumbling window trigger, you need to make sure that actually that tumbling window trigger succeeds so that the other one succeeds as well. I hope there will be some changes to the data factory from Microsoft to fix this, but at the moment this is how it works. But I hope I've given you enough information about the current behavior of the triggers and pipelines within the data factory. And that's the end of this lesson. I'll see you in the next one. Okay, welcome back. In this lesson, we're going to look at metrics. So when we looked at the dashboards, we saw the 3 metrics or even 6. So that was the pipeline activity and trigger, successful runs, and the failed runs. So that is all we got access to in this dashboard. But if you want to look at the other metrics available within Data Factory, you will have to come into the notifications, alerts, and metrics, and you can click on metrics, and that takes you to Azure Data Factory. So instead of going through the options within Data Factory to come to Azure Monitor, you can come straight to Azure Monitor from your Azure portal. And you need to click on metrics here, and now that will list you all the resources available within your subscription. And we got our resource within the COVID reporting RG, and the Data Factory is the COVID reporting ADF. Let's select that, and if you click apply, you can see all the metrics available within Data Factory. So that'll be the cancelled activity runs, elapsed time for the pipeline run, which is quite useful, and you've got the failed activity runs, and then you've got the integration runtime metrics there. You've got a couple of metrics on the Data Factory itself, so which is the allowed entities count and the allowed Data Factory size. And similar to that, you would have the total entity count and the total Data Factory size at the end as well. And in between, you've got the succeeded and the stuck SSIS integration runtime and all of that, which is quite useful. So you've got a lot of metrics here, and you can play with them here instead of just relying on the metrics you've got available within Data Factory. So this allows you to create charts which you can pin to your dashboard, and you can look at them as well. In order to make it simpler, let's see whether we can get the succeeded pipeline runs. So I'm going to do succeeded pipeline run metrics, and we've done a sum, so you've got the option to sum, count, aggregate, and things like that. So let's do a count, which is more appropriate for this. And you can look at it over 24 hours, as you can see here. So you've got the over 24 hours, you've had 2 around 3 o'clock, then 2 around 1 o'clock, and then you've had the 4 at midnight. Because that's where I've got the triggers scheduled to run at the moment. And you can filter that to last 12 hours, last hour, or you've got plenty of options here. You can do last 7 days or last 30 days, and you've got the custom, which will let you change any from and to within the last 45 days as well. And if you click apply, so you've got that, and you can change this from a line chart into a bar chart, for example, or scatter plot or whatever. So let me change that to bar chart. As you can see here, when you come in the morning, you can see what's happened that day by looking at the last 24 hours. That is quite useful. And if you have one like this for a failed run, so that'll be on your dashboard, you can very quickly look at it and then come back and fix the issue. So in order to pin this to dashboard, you can just click here, pin to dashboard, and we got this dashboard for COVID reporting project. So let's pin to that one. And you can pin there, and you can also share your dashboard as well. So let's do pin to dashboard. And if I go back to my dashboard here, so that is our dashboard. As you can see here, I've had one of them. I had this one previously, so this is the one we just pinned, which is the count succeeded pipeline runs metrics. So you can build a whole dashboard with all the metrics you want available when you come in the morning to look at, and that'll be quite helpful. And that's the way you make use of the metrics available to help in supporting the Data Factory. So that's the end of this metrics lesson. And in the next lesson, we'll start looking at how to set the diagnostic settings within our Data Factory and look at the richer metrics that's available within Data Factory logs. I'll see you then. Okay, welcome back. In this lesson, we're going to look at the capabilities of Azure Monitor that can help with monitoring our Data Factory. Let's switch over to the Azure portal and get started. Okay, here we are in the Azure portal. Let's search for Monitor. And that's the Azure Monitor. Within that, you've got the diagnostic settings and the settings. So click on that one, and you can see all the resources we got, which we can set the diagnostic settings for. And if you don't see them, make sure that actually you select the right
ఆయన బస్ అని చర్చిస్కు బస్ అని పో పిలిచాను
description, and then you'll see those. In our case, we got the data factory. The one we're working on is the COVID reporting area. So let's click on that one. As you can see here, you can click on the Add Diagnostic Settings to collect the data into your choice of storage. So let's click on the Add Diagnostic Settings, and you need to specify a diagnostic setting name. So I'm going to call this as your Data Factory Metrics. Here you've got the choice to collect the logs you want as well as the metrics. Now that we've successfully created a release pipeline to continuously deploy the ARM template to the test data factory, let's discuss the pitfalls so that we can rectify them. Firstly, this pipeline doesn't... Okay, welcome back. In this lesson, we're going to look at metrics. So when we looked at the dashboards, we saw the 3 metrics or even 6. So that was the pipeline activity and trigger, successful runs, and the failed runs. So that is all we got access to in this dashboard. But if you want to look at the other metrics available within Data Factory, you will have to come into the notifications, alerts, and metrics, and you can click on metrics, and that takes you to Azure Data Factory. So instead of going through the options within Data Factory to come to Azure Monitor, you can come straight to Azure Monitor from your Azure portal, and you need to click on metrics here, and now that will list you all the resources available within your subscription. And we got our resource within the COVID reporting RG, and the Data Factory is the COVID reporting area. Let's select that, and if you click apply, you can see all the metrics available within Data Factory. So that'll be the cancelled activity runs, elapsed time for the pipeline run, which is quite useful, and you got the failed activity runs, and then you got the integration runtime metrics there. You got a couple of metrics on the Data Factory itself, so which is the allowed entities count and the allowed Data Factory size, and similar to that, you would have the total entity count and the total Data Factory size at the end as well. And in between, you got the succeeded and the stuck SSIS integration runtime and all of that, which is quite useful. So you got a lot of metrics here, and you can play with them here instead of just relying on the metrics you got available within Data Factory. So this allows you to create charts which you can pin to your dashboard, and you can look at them as well. In order to make it simpler, let's see whether we can get the succeeded pipeline runs. So I'm going to do succeeded pipeline run metrics, and we've done a sum, so you've got the option to sum, count, aggregate, and things like that. So let's do a count, which is more appropriate for this. And you can look at it over 24 hours, as you can see here. So you got the over 24 hours, you've had 2 around 3 o'clock and 2 around 1 o'clock, and then you've had the 4 at midnight, because that's where I've got the triggers scheduled to run at the moment. And you can filter that to last 12 hours, last hour, or you've got plenty of options here. You can do last 7 days or last 30 days, and you've got the custom, which will let you change any from and to within the last 45 days as well. And if you click apply, so you got that, and you can change this into from a line chart into a bar chart, for example, or scatter plot or whatever. So let me change that to bar chart. As you can see here, when you come in the morning, you can see what's happened that day by looking at the last 24 hours. That is quite useful. And if you have one like this for a failed run, so that'll be on your dashboard, you can very quickly look at it and then come back and fix the issue. So in order to pin this to dashboard, you can just click here, pin to dashboard, and we got this dashboard for COVID reporting project. So let's pin to that one, and you can pin there, and you can also share your dashboard as well. So let's do pin to dashboard. And if I go back to my dashboard here, so that is our dashboard. As you can see here, I've had one of them. I had this one previously, so this is the one we just pinned, which is the count succeeded pipeline runs metrics. So you can build a whole dashboard with all the metrics you want available when you come in the morning to look at, and that'll be quite helpful. And that's the way you make use of the metrics available to help in supporting the Data Factory. So that's the end of this metrics lesson. And in the next lesson, we'll start looking at how to set the diagnostic settings within our Data Factory and look at the richer metrics available within Data Factory logs. I'll see you then. The metrics. So let's get all the metrics, and let's get the activity pipeline and the trigger run logs. We don't have any SSIS packages, so we don't worry about that. And this is the important thing. So you can route these to any of these 3 kind of storages. So you can send them to a log analytics workspace, or you can send them to a storage account or to an event hub. So if you click on that one, it'll ask you for a log analytics workspace. And if you click on this one, it's going to ask you for the subscription to which you want to add the data. And if you wanted to send it to event hub, you can click on that one. And you can choose all 3 as well. Let's start with the storage account. We already have a storage account for our project, so which is the COVID reporting SA. So let's select that one, and we just need to save it. So let's save. So what happens from now is all the log information for these, as well as the metrics for our Data Factory, will also be sent to the storage account. And we can set a policy on the storage account to delete the data after a certain time, otherwise it will be kept forever. So what this gives us is actually in Data Factory, you've got the limitation of 45 days for which you can keep the data for, but here you can keep it for longer. And also within Data Factory, you can only see the metrics, but here you've got the logs as well, so it is much more nicer. In terms of setting the retention policy, you've got 2 options. One, you can set the retention policy here. So that means you can say you want your activity runs to be kept for 60 days and pipeline runs for 45 days, so you've got control over each of the containers. Because when the data gets returned to a storage account, they all go into separate containers. Or you can leave it as 0. 0 is the default, which will be there, logs are kept forever. The other option to set retention is leave them as zeros, but you can set the lifecycle policy on the storage account yourself. So you've got the 2 choices, but I'm going to set here, I'm going to set all of them to just 1 day because it's just for demo purposes. Let's do that. And I'm going to click save. And before we head over to the storage account to see the logs being written, we need to at least run a pipeline or a trigger so that we got some data being written. So I'm going to rerun this trigger to ingest the CDC data one more time. It's not going to harm anything, so let's click OK here. And that should be running now. Yes, that's waiting. Okay, the trigger has now finished completion. So we can switch over to the storage account and have a look at the data. But sometimes it does take about a couple of minutes before the data gets returned to the storage account. So let's switch over to the Storage Explorer and have a look at our containers. So let's do a refresh on the COVID reporting SA. and we should have new block containers. So we got the 3 block containers for the logs and 1 for all the metrics. Let's have a look at one of these containers. So let's go into trigger runs and just click through the folders to get to the JSON file at the end. And that's the JSON. So let's open that one, and we should be able to see some statuses of the trigger all the way through. So you got all the information here. So you can use this in one of your applications. So it kind of tells you when it started, when it started running, waiting, succeeded, and all of that kind of stuff. You can report from this data, and this data could be kept for more than 45 days. So that is everything about the diagnostic settings being written to storage account. In the next lesson, we'll have a look at writing the diagnostic settings to log analytics and also try and create some queries to report on those. I'll see that. Welcome back. In this lesson, we're going to look at how to set the diagnostic settings so that our metrics and logs are written to the log analytics workspace. So in order to do that, first we need to have a log analytics workspace. So let's create that. Come to the top and click create resource and look for log analytics. So this is the log analytics workspace we want to create. Click create on that one and pick a resource group. So that goes under COVID reporting OG. And I'm going to call this one as COVID reporting WS. And it's going to be in my UK South region. And let's look at the pricing tier. There's only one option available for me. In Legacy, you had multiple options, but this is now per gigabytes. So let's click through to next and review plus create. So validation passed, click create to create the workspace. So that's now being deployed. The deployment is now complete. So let's go back into our dashboard and pick our data factory. So that is the COVID reporting project, and that's our data factory. So go into the diagnostic settings. Last time we did it from Azure Monitor, but this is another option you can do. And then we can go into edit the settings on the diagnostics we set up in the last lesson. And now you can send to log analytics workspace as well. So this is what you want to click, and subscription start, and it's already picked up the log analytics workspace that we've created. And you've got 2 options. So one is the Azure Diagnostics and the other one is the resource specific. So we want the resource specific because the Azure Diagnostics option puts everything into one table, and depending on which metric you're looking at, you've got to look at specific columns. That is quite annoying when you come to query the data, but resource specific will create separate tables for each of the metrics and each of the logs, and it's quite nicer to query the database. So let's pick resource specific and click save. And like we did last time, we're going to rerun our trigger so that some of the data gets pushed into log analytics. Let's rerun this trigger one more time. Okay, the trigger and the pipeline has now finished completion. So let's go back to our Azure portal and let's find the log analytics workspace that we created. We didn't pin that into our dashboard, so let's go to all resources and then click on the type and let's look for the log analytics workspace. So log analytics. So we only have one log analytics workspace, so it's quite easy to find. So that is the one we created. And let's pin this before we forget about it so that it's there on the COVID reporting project dashboard when we need it next time. So that's been pinned. So this is your log analytics workspace and all the data comes here. And you've got the option to go and query the logs. So under general, you can find the logs here. So if you click on that one and then click get started. So it gives you lots of useful queries and things like that, but let's close all of this for now. And as you can see, you've got the log analytics workspace with these tables already. So you've got the activity run, pipeline run, trigger, and then you've got alerts and some more usage information within those things. In order to query these tables, you would have to use a language called Push to Query language, which is quite powerful. It's quite easy to pick up if you already know some query language, like SQL as an example. There is quite a lot of help available within the Microsoft website, so let's go and find that. I'll put you in the right direction there. So if you just search for Push to Query language, you'll find that. So if you click on this link, it should take you there. So that tells you how to get started with Push2, and then you've got the tutorial which tells you how to query tables, and it gives you everything you need basically. So for example, if you want to query a table and get the total number of records, then you would do the count. So, and if you want to do back classes and things like that, this is kind of how you would go about doing that. And you can project the data into separate columns here as well. And if you want to only pick a certain number of records, you go for a table name and then take 5 in this case. That's how you do that. Let's go and do a couple of those. So say for example, we want to query our trigger run table, and then we want to count the number of records. You would have to do count in here, and then if you click run, it should tell you there are 3 records. So let's see what those 3 records are. You just have to put the table name and hit run, it should run. And as you can see here, we've had the trigger come in waiting, and then you've got it running, and then it succeeded. So it takes the information, it's a snapshot of the status at every point in time. It's kind of like telemetry being pushed into log analytics. And you can query this data, you can summarize, you can join all of these tables as well. So I'll show you some more help. So if I go and query for join, search for join, sorry. So as you can see here, if you want to join your triggers with pipeline runs, then you would do a join like this. And there is enough help here for you to be able to get up and running. And the good thing with these things is you got one log analytics workspace now with our data factory being hooked up to. You can hook this up to any number of data factories, and all of the log information would come in here. And when you query the area trigger run, it's going to give you all of those in one go. So you can report across multiple data factories. Unlike within the data factory, you're only seeing that data factory information. Also, log analytics gives you a lot more capabilities, so you can create your own visualizations and pin them into your dashboards if you wanted to, or you can create workbooks as well within log analytics and have your dashboards. So we'll look at the capabilities of that in the next lesson. That is an optional one. Feel free to skip it if you want to, but I'll show you a bit more of the capabilities of log analytics in the next lesson. So I'll see you then. Okay, welcome back. In this lesson, we're going to look at a few more capabilities of log analytics and what it's got to offer. This is slightly away from our core objective of this tutorial because that was going to be on Azure Data Factory. So this is optional. So if you want to skip this lesson, please feel free to do so. But I think it is quite useful if you learn about Push to Query language and how to use it because that'll come in handy when you come to monitor data factories at large scale. So it's up to you. Let's make a what I've done is I've run a few more triggers overnight, and I've got more data to look at so that we can make some meaningful summarizations or aggregations within this data. So as you can see, we got a lot of data in here, And we got some on waiting on dependencies, some running, some succeeded. But the way Data Factory works with log analytics is every time there is something happens, it just sends the message to log analytics. So this is like a telemetry. So you've got all the information about a particular trigger, for example. So it's not only the latest information, it is everything. So as you can see here, the TRC equalized hospital admissions data has got 2 records here. One of them is running, so it started running, and then it succeeded. It won't be alright if we just say this many are running, whereas actually they have succeeded. So we need to do some summary and get the latest status of a trigger so that when you look at the monitor, you know actually, okay, I'm looking at the latest status. What I'm talking about is actually you want to see something like this. So this tells you the latest status. So we will try and create one of these dashboards. So let's say we'll create the trigger dashboard, and we had 6 successful runs of the trigger from when we created the log analytics workspace and did the diagnostic settings for Data Factory to push the telemetry into log analytics. So let's try and see how we do that if we come across to the log analytics workspace. So first thing we want to do is we want to get the latest status. In order to do that, let's say we got time generated in here. Let's get the latest time generated for each of the triggers, and then we can join back to the same table to get the status. So let's do that. In here, you can just do summarize, and you can say time generated equals, and we want to say max time generated because that's the one we're interested in, and we want to say by trigger ID. Each one has got a unique ID within this data, so that's what we're using. And we want to now project this information, so which is our trigger ID and time generated. So if I run this one, so this is what you get. And in order to do the add a join back to the same table, we'll have to keep that within a variable, but we'll do that in a minute. But before that, let's do area trigger run. And now we want to join back to that data. When you join back to that data, we want to name that one. This is similar to, say, creating an inline view within a SQL. So the way you create variables is do let commands. And I'm going to call this one as latest area trigger run equals. So now that variable would have that data. So you can even query that data if I just do this. And I'll show you what happens. So I've set the result of this query into this variable, and I'm just executing that variable in these 2 commands. So let's select that and run it. We get the same result. So let's get rid of that now, and then join back in here. So using join, now I want to join to the latest trigger run. And now you want to specify the conditions. Here we want to join based on the trigger ID and the time generated. So these 2 data sets are now joined. And now we want to do a summarize on the summarize to get the counts used by your status. So I'm going to do summarize count by status. So we should see the 6 records come out, and we want to project it so that we can run it. So let's do project, and you can do status and count. I want to see the 6 records being output. So as you can see, we got 6 succeeded runs. So in the Data Factory dashboard itself, we saw a pie chart as well actually for the succeeded runs. You can do exactly that in here as well. So if you just do render, and then you can do a pie chart. So if you do that and run it, you get the pie chart here. So we got the 6 succeeded runs here. And if you wanted to pin this to our dashboard, you can do that as well. So if I just come here and then pin and to the COVID reporting dash project, let's do that. And I can see what's happened in the dashboard. Let's have a look at that. No, I haven't got that. So let's go to my dashboard again, and that's our COVID reporting dashboard. And we got the analytics, so you got the 6 succeeded counts in a pie chart. This is just a simple example, but you can create complex queries. You can join your triggers to pipelines, and you can even report on your trigger names. So let's do that quickly. Here we've reported on the status, but let's try and report it on the trigger name. So let's do trigger name, and if you just replace that here, and then it won't make sense to do it on a pie chart. Let's do a bar chart for this one. So it should tell you how many triggers ran and how many times they ran as well. Okay, so as you can see here, these triggers ran once, and this one ran 2 times. Also, instead of pinning this to the dashboard, we can create a workbook within log analytics itself. So in order to do that, you can come into workbooks here under general, and you can click on empty to create a new one. But you do have a lot of templates already given by Microsoft, so have a look around those. But I'm going to go into empty, and then you can add, say for example, we can add a text and just say trigger runs. And that's done. And you can add a query now, and this will be, say, for our query, which is the render bar chart. You can run the query, have a look at the output here. Yeah, so you got the output here for the query that we ran. So we got the interest CDC data command twice, and the others have run once. You can format the bar chart as you wish, but let's do done editing. And then you've got the workbook created with your trigger runs listed here. And similarly, you can create any number of charts you want to create, and you can share this with your rest of the team, and you can save the workspace, and you can use this to monitor your pipelines and triggers. So that is quite handy as well. So that's the end of this lesson, where we've used the log analytics workspace to create our charts, and we've done aggregations and things like that within the queries. In the next lesson, I'll show you an out-of-the-box solution given by Microsoft, which will help you get started. So I'll see you then.
యాడా చచ్చిపోయినా
Welcome back. In this lesson, we're going to look at a solution given by Microsoft.
వస్తలే
In the marketplace that you can use to monitor multiple data factories at the same time using one dashboard. Having said that, this is quite a simple solution. So if you have a complex requirement, the best solution is to go into log analytics and create your own dashboards, or even take this as a starting point, and then you can update this dashboard. So let's get started. In order to do that, come to the top left and click create a resource, and then the marketplace, search for Azure Data Factory Analytics, and it's the last one here, and click on preview, and then click create. And in order to create a new solution, you need a log analytics workspace. So we can attach our existing log analytics workspace, which is the COVID reporting WS, and then click create, and it should create the solution for us. Yeah, that's done. Go to resource, and we've got the solution here. So in this solution, you get workbooks out of the box. So that's the main thing about this. So click on workbooks. And as you can see here, as your Data Factory Analytics workbook is here, and click on the workbook, and then it will open up. And as you can see here, you have already pre-canned data reports or the charts. So you got the time range here. You can adjust the time range, maybe in 5 minutes on to 90 days. And you can, as you can see here, the first one is pipeline runs by Data Factory. So within the last 48 hours, I've got 12 pipelines run through, and it also tells you whether they've succeeded, queued, or all of those things. And you've got the activity runs by Data Factory, and it gives you the trigger runs by Data Factory. I've got 20 triggers, and you've got the area of errors. If there are any errors, you'll see them. You've got the top 10 activity errors as well. So there are plenty of reports you've got here. Activity runs by type, what kind of activities we've had. So we've had 20 copy activities, 4 lookups, and 2 for each, and etc. So this is quite good to get you started. But if it doesn't satisfy your requirements, you can even amend this one. So in order to do that, you can click on edit, and you get the ability to edit these queries. So if you want to edit the query, that produces this donut. So you have to click on edit, and then you just change what you want to change. So in this case, you've got the area of pipeline where time generated is whatever the time range you've given, and then the status is not equal to in progress, and then it's summarized by one ID, and it's rendered that into a pie chart. So this is again using the Crystal query language. So if you want to put your own query, you would do that, and then you just have to save the output. And you can save this as a separate workspace, and you can share it with your colleagues, and you can monitor the dashboard that way. So that's everything about the solution Microsoft provides as your starting point for using log analytics to monitor your data factories. So that's the end of this lesson, and I'll see you in the next one. Welcome to a new section on continuous integration and continuous delivery, or otherwise referred to as CI/CD. Now that we're familiar with developing Data Factory pipelines and created a complete data engineering project using Azure Data Factory, it's time to look at delivering and deploying the project to higher environments such as test and production. Also, we want to be able to configure the development Data Factory with a source control tool to enable collaborative development. In this section of the course, we'll look at how to configure Git with Azure Data Factory and the development process. We'll then look at the build and release pipelines to enable continuous integration and continuous delivery of the Data Factory code. Along the way, I'll give you an overview about DevOps and the CI/CD process. Also, I'll take you through the Azure DevOps service using which we'll be creating the build and the release pipelines. By the end of this section, you will have a good understanding about what continuous integration and continuous delivery is, and also how to enable CI/CD for Azure Data Factory projects. Let's get started. Continuous integration and continuous delivery, or otherwise referred to as CI/CD, is one of the DevOps practices followed to achieve faster time to market as well as increased confidence in delivering software applications. I'll give you a quick introduction to continuous integration and continuous delivery in this lesson. As I said, CI/CD is one of the DevOps practices, so let's start with an introduction to DevOps. Traditionally, companies had separate development and IT operations teams. Development teams were responsible for writing code and testing them, and operations teams were responsible for deploying and supporting that code in production. Having said that, siloed teams had its own issues, such as communication issues between the teams, conflict of interest due to their own team's priorities, lack of automation, etc. The end result is that companies couldn't bring products to market as quickly as they wanted to, and also when delivered, the quality of the product wasn't as expected. In order to solve these problems, companies wanted to bring the development and the operations teams together. The intersection of the responsibilities between these two teams is called DevOps. The DevOps movement began around 2007. The primary objective of DevOps is to bring together developers and IT operators to work collaboratively on a project throughout its lifecycle and increase the speed and quality of the software development and delivery. As you can imagine, this requires not only the cultural shift in terms of collaborative working between the teams, but also the tools and technologies required to integrate and deploy the code continuously and in an automated manner. Let's take a look at the general characteristics of DevOps teams. As we discussed, DevOps teams work in a collaborative manner, and there is trust and transparency between the team members. They tend to follow agile project management and software development approach, which helps teams to deliver work faster in smaller increments. The iterative approach to software development helps observe the impact of small improvements to the application and build on it. Continuous integration and continuous delivery helps bring together the development and the deployment of the application and removes the issues faced by the siloed teams. It also increases the speed to market and the quality of the software being delivered. DevOps teams tend to automate not only the integration and the deployment of the code, but also automated testing and monitoring are essential characteristics of these teams. And finally, continuous improvement is an essential part of DevOps teams. They observe not only the state of the builds and releases, but also the performance of the application. So it's essential to gather metrics about the performance and feedback to the developers to improve on. That's a brief introduction to DevOps. Now let's focus on continuous integration and continuous delivery, which is the main focus of this section. Let me first talk you through the approach of delivering software applications in modern teams, and then I'll explain which areas are considered as continuous integration and continuous delivery. Usually, you have an idea for a software application, and you go through the following steps to produce that application. The first stage is planning, in which you will gather the requirements, write user stories, break down the tasks, and plan the work for a sprint or an iteration. Developers then start coding the software, which then gets built. For example, if your code is in Java, you may build Java files. The build then goes through testing, and once testing is completed, it gets released and deployed to the necessary environments. The job doesn't stop there. Once you've deployed your application, you may want to monitor and improve the quality of the application. That means more planning, coding, testing, releasing, deploying, and the cycle goes on. Software development teams consist generally of more than one developer, so the code needs to be continuously integrated to a source control system such as Git, and build is taken for every code merge, and we run some automated testing. So this is called continuous integration. The tested code then needs to be released and deployed. Some companies tend to continuously deploy the code to production, and others tend to have a quality gate or an approval process, which is a manual step. That's the difference between continuous delivery and deployment. Continuous improvement is achieved through observing the performance of the application and acting upon that. Now that we understand what continuous integration and continuous delivery is, let's talk about it from the perspective of Azure Data Factory. You might be wondering what forms of code in ADF, because we're just dragging and dropping objects to create a pipeline. Behind the scenes, every object in Azure Data Factory can be represented by a JSON file. So that is our code. Now let's talk about build. As we know, if we build a Java project, we get a Java file which we can deploy to other environments. Similarly, if we build an ADF project, we get something called an ARM template. If you're not familiar, ARM or ARM stands for Azure Resource Manager, which is Microsoft's deployment and management service for Azure. ARM template basically contains the configuration of our project, and it's also in JSON format. We can use this to deploy our project to other environments. As you know, if you work with programming languages, you can write unit tests and execute them before deploying to other environments. But automated testing of integration tools such as ADF is not that easy, so many projects tend to rely on manual testing. So we'll leave that section out of this course. Having said that, there is a .NET framework available for testing ADF code, and I'll leave a link to that in the course notes. Once the testing is complete, we then have to release and deploy the ARM template to the higher environments such as test and prod. This will create the ADF objects such as pipelines, triggers, data flows, etc. in the appropriate data factories. There are some nuances around this which are specific to ADF, and we'll discuss them later. Hope you now have an initial understanding about continuous integration and continuous delivery in relation to ADF. And that's the end of this lesson. I'll see you in the Now that we understand what CI/CD is, in this lesson we are going to take a deeper look at how to implement continuous integration and continuous delivery for ADF artifacts. The practice of CI/CD for ADF components has been evolving over time. And up until a year ago, Microsoft's recommendation was to do a manual build using the publish button within the Data Factory Studio and have an automated deployment using release pipelines. Vast majority of the projects in the industry are still following this solution, but since then, Microsoft released a package to do an automated build which could be used in the DevOps build pipelines. And the fully automated solution is the recommended solution for any new projects. We are going to refer to the approach of using ADF Publish to do a manual build and automated deployment as option 1. This is also referred to as ADF Publish option in the industry. I would highly encourage you to understand this because there are many projects still using this approach. I'll walk you through this approach in this lesson. We're going to refer to the fully automated solution as option 2, and this will be covered in a later lesson. Please don't jump straight to that lesson, as it's important to understand option 1 first. There is also another option which uses a third-party service called ADF Tools, and that's available via the marketplace. We won't go into detail on that, but I'll leave you with some links and documentation for that. Let's start with option 1, and first let's recap the process we've been following so far to develop our COVID-19 project. We've only had one developer on this project, and that's you. We've opened the Azure Data Factory Studio and created the necessary data factory objects such as pipelines, data flows, triggers, etc. We then debugged the pipelines. Once we were happy with the changes, we clicked on the publish button, which carried out the validation of the objects, and if there were no errors, it then stored the objects to the Azure Data Factory repository. The key point to remember here is that we directly connected ADF Studio to the ADF repository and made all the changes there. This way of connecting to the ADF repository is referred to as live mode. Even though working on the live mode was reasonable for our course, it's not sufficient for industry projects due to various reasons. First of all, it's likely that we will have more than one developer in any project, so we need to have a solution where the developers can collaborate. For example, without having a source control option for the developers, they may work on the same pipeline and override each other's changes. And also, live mode doesn't give us the ability to version control, so we cannot roll back the changes. Also, there is no capability to perform reviews either. In order to provide these capabilities, we need to enable a source control solution such as Git. We can enable the Azure Data Factory Studio for the developers to use Git as the core repository. This way of connecting ADF Studio to Git is referred to as Git mode. ADF supports GitHub as well as Azure DevOps repos as the core repository. We'll use Azure DevOps repos for this course, but you just have to follow very similar steps to set up GitHub as the core repository. With the introduction of Git, the developers now can create separate feature branches to make their changes and work collaboratively. The developers can save their changes by committing to the feature branch as they go along and also request for reviews, etc. Once the changes are approved and the feature branch is merged to the master, we can do a publish to the data factory. The publish option not only publishes the changes to the ADF dev repository, but it also creates another branch in Git called ADF publish. This branch will contain the ARM templates we were talking about earlier. In summary, the publish button is basically performing the build element of our continuous integration. The ARM templates can then be deployed to the higher environments, such as test and prod, using a Azure DevOps release pipeline as part of the continuous deployment. As you can see, I'm talking about a manual publish or the build of the code in this solution. So we have a manual process for the build element of the continuous integration and an automated deployment in this option. Hope you now have an understanding about option 1, but don't worry, if you still have questions, they'll all be answered once we've created the first CI/CD pipeline. That's the end of this lesson, and I'll see you in the next one. Welcome back. In the previous lesson, we talked about using Azure DevOps as the tool for code repository as well as release pipelines. So we need to create an Azure DevOps service for our project, but before that, I would like to give you a quick introduction to Azure DevOps and what it is. Azure DevOps is basically a software as a service platform or a SaaS platform offered by Microsoft on Azure Cloud with the necessary tools required to implement a DevOps project from end to end. It offers 5 key services, and let me walk you through each of them quickly. Azure boards provide the management capability. Using the boards, you can plan a project work, track progress, collaborate with team members, etc. It supports the capabilities required to manage Agile, Kanban, as well as Scrum processes. It also provides the capability required to produce custom reports to track progress. Azure Repos is a source control capability that you can use to manage your code. It currently supports the most popular version of the source control system called Git, as well as TFBC, which stands for Team Foundation Version Control. Azure pipelines provide build and release services to support continuous integration and continuous delivery. And as the name suggests, Azure test plans provide a browser-based test management solution. It provides all the capabilities required for planned manual testing, user acceptance testing, and exploratory testing. It also provides the capability to gather feedback from stakeholders and respond to them. And finally, Azure Artifacts is a library service which can be used to store packages or development artifacts that can be shared or used within the project, for example, in a CI/CD pipeline. Let me also quickly walk you through how projects are organized within Azure DevOps. When you connect to Azure DevOps, you will be connecting to an organization. An organization is nothing but a container for a collection of projects. A company may choose to have one organization for the entire company, or it may choose to have multiple organizations. For example, one for each of the business units. This depends on how the company wants to keep things separate from each other and also the security model. You can then create projects within an organization. Each project will have its own boards, repos, pipelines, test plans, and artifacts. You can also create teams, and a team can work on more than one project, etc. But to keep things simple, we won't worry too much about those here. I hope that's given you an introduction to Azure DevOps and how things are organized within Azure DevOps. And that's the end of this lesson. I'll see you in the next one. Welcome back. Now Now that we understand what Azure DevOps is, in this lesson, we are going to sign into the service and create a DevOps organization and a project for us to do our work. I'll also give you a quick tour around the service. Let's switch over to our browser and get started. Here we are in the browser. You can access the Azure DevOps service via dev.azure.com, and that'll bring you to this page here. You don't have to sign up for the DevOps account because you already have an Azure account. So let's just click on sign into Azure DevOps and pick the account using which we want to sign in. So I'm going to go for the az.adm and then key in the password and click sign in. And I'm going to leave these details as they are and click continue. And that'll bring you to this page here. Please don't click continue here. We need to pick the right directory. So click on switch directory. As you can see here, by default, our DevOps organization was going to be attached to the directory Microsoft account. But we wouldn't want that. We want our organization to be attached to the directory under which we are creating our Azure resources, such as Azure Data Factory. So in order to find out the directory to which we want to attach our organization to, we can navigate to the Azure portal and find the directory from there. So if I go to portal.azure.com, as you can see here, my account here is attached to default directory. So unless you haven't made any changes, you're going to have default directory as well. But if you are working in an organization, you might not be using the default directory. There will be separate directories for you. So find out the one under which you're creating your Azure resources, and that's the one we want to attach our DevOps organization to. So let's pick that. In my case, it is the default directory. So that's the only one I've got other than the Microsoft account. So let's click on default directory and then click continue. So I'm going to pick the country and the region, so it's going to be United Kingdom for me. So let me name my organization. I'm just going to simply give my name, so that's going to be Ramesh Ratnaswamy, and let's key in these characters. And let me click continue, and that should create the DevOps organization for us. And let me sign in again, so that's my account, and that should now take us to the organization. So here I am in Azure DevOps, and as you can see, I've got an organization called Ramesh Ratnaswamy, and if you click on the organization settings, you will see the details about the organization. As you can see, under the overview tab, we've got the organization name. So in my case, it's Ramesh Ratnaswamy. One thing I forgot to mention is that the organization name has to be unique. If you have a common name, you might not be able to use that. So in that case, just add a couple of numbers or characters to the end to make it unique. And also, as you know, the one other thing we did is we attached to the Azure Active Directory, and that was the default directory. So if you click on this, you will be able to see the directory it's attached to. As you can see, in my case, I've attached to the Azure Active Directory, which is the default directory. So that's what I expected to do. Let's now navigate to billing. As you can see here, this is where you can set up billing, but in our case, we don't have to set up billing because we get a lot of things for free, and that's more than sufficient to do our project. So as you can see here, we get 1,800 free minutes on the MS hosted CI/CD pipelines, and then you get a self-hosted CI/CD pipeline, as well as actually you can have up to 5 users for free for the boards, repos, and test plans. Also, you get 2 gigabytes of artifacts as well, so that's more than sufficient to do the exercises for this course. Having said that, there's one thing Microsoft restricts is being able to run parallel jobs. Having said that, you don't need to pay anything additional for that. That's part of the free tier. You just have to complete a form and send it across to Microsoft, and they'll enable that within 2 working days. So let me navigate to that form and complete it while we're here. So that is in the location aka.ms/az pipelines-parallelism-request. I will include the link in the course notes, but if you need it, it's here as well. And you just have to complete this form. So I'm going to give my name and my email address. And here you need to specify the name of the DevOps organization, which you can get it from here. So if you come over to DevOps and then click on Overview, and you just need to copy this URL here. So let me copy that, and let me move over to the form, and let me paste that. And are you requesting a parallelism increase for a public or a private project? We're going to create our projects as private projects. So I'm going to just click on private, and let's click submit. And this will take between 2 to 3 working days. That's what Microsoft tells us. So we'll come back in a day or two and see whether we've got the parallelism enabled. We don't need this parallelism in order to create our repos or work on the repos, and that's what we'll be doing in the first few lessons. We'll need this in order to run our pipelines, but that'll be later down the course. So by the time you come to the pipelines, hopefully the request will be approved. Here's the email that I received from Microsoft stating that my request for parallelism has been completed, and to be honest, I was quite surprised. It took less than 24 hours for them to complete the request and send out the email. So hopefully yours will come through within a shorter period of time as well, rather than the 2 to 3 working days. So let's now switch over to Azure DevOps. Now we need to create the project. So there are a couple of options. You can just click on projects here and then click on a new project, or you can click on Azure DevOps here and I'll take you to your organization. And as we saw previously, you can create a project from here as well. So let me give a name for our project. I'm going to call my project as Azure Data Factory CI/CD. You can give a description as well, a meaningful description here, but I'm going to leave that as blank. And as I said before, we can keep our project as private. And if you click on advanced, you will see the version control tool that's going to be used for our project. So you've got the option of Git and Team Foundation version control. We're going to use Git for our project. And you can pick the work item process as well. So this will be important in your boards. So you can pick Agile, Basic, or Scrum, or CMMI. I'm just going to go simply with Basic because we're not going to do much in that space. So I'm going to click Create Project. Let me very quickly talk you through this page. As we discussed previously, the hierarchy of projects is within organization. That's what you're seeing on the top left here. As you can see, Ramesh Ratnaswamy is my organization. Within that, we've got the project called Azure Data Factory CI/CD. Within that project, we've got the 5 key services we talked about, which are the boards, repos, pipelines, test plans, and artifacts. If you're running an Agile or a Scrum project, you're going to need the boards. So within the boards, you can create your work items, you can have a Kanban board, backlogs, you can manage your sprints and things like that. And repos is where you can keep your code, which is basically a Git repo. We're going to look into that. And pipelines is where you can create your build and release pipelines, and you can create your variables, environments, and things like that. And as we discussed before, you can create your test plans here, and the artifacts live here. We're not going to worry about the boards, artifacts, and the test plans. We're just going to be using repos and pipelines. So all our code from Azure Data Factory is going to be stored within these repos, and we're going to create build and release pipelines here. So I hope you've now got a good understanding about Azure DevOps and how to navigate to a project and the repos and pipelines and things like that. So that's the end of this lesson. I'll see you in In this lesson, we're going to create the data factory resources required for this module. Just so you're aware, we're not going to use the data factory that we used for our COVID project. Instead, we'll create some new ones. This is so that we can have a clean start and apply CI/CD from the beginning and also see the effect of that. We can also apply naming standards to help with the CI/CD process. let's first take a look at the number of data factories required. Generally, every DevOps project will have a dev data factory and a production data factory. Also, there can be one or more test data factories. Some projects tend to have one for integration testing, one for user acceptance testing, etc. To keep it simple, we're going to have just one test data factory. As we said before, we're going to enable Git for our dev data factory so that we can do continuous integration of the code. The code, test, and production data factories, as you know, will be deployed via release pipelines. Now that we understand the number of data factories required for our project, let's come up with some naming standards. It's important to have some naming standards and be consistent with them so that we can use variables in our release pipelines and reuse the code. Our data factories will be given these names shown here. It's best practice to keep the data factories in separate resource groups which are specific for their environments. So we'll also do that. As you can see here, I prefixed all of the resource names with the environment and kept the rest of the name as the same. Also, as you can see, only the dev data factory will be enabled as that's where the development will happen. Now that we understand the requirements for the data factories, let's navigate to the Azure portal and get started with creating them. Here we are in the Azure portal. Let's click on create a resource and search for data factory in the marketplace, and let's click create to create the data factory. I'm going to pick my pay-as-you-go subscription, and as we discussed, we're going to have new resource groups for each of our data factories. So let's click on create new and key in the resource group name that we discussed previously. So this is going to be for the dev data factory, so that's going to be dev CACD demo org. And we need to give the name of the data factory. Again, this is the dev data factory, which will be dev CACD demo ADF. And we need to pick the region. I'm going to go with my closest region, which is UK South. And we want the version 2 of the data factory. Let's click next to Git configuration. We know that for our dev data factory, we need to enable Git, but we'll do that within the data factory studio. So let's click on the configure Git later and accept the defaults for networking advanced tags. And let's click on review plus create. And the validation has passed, and I'm going to click create. Whilst that data factory is being created, I'm going to create the other two as well. Okay, we got all three data factories now created. Let's go over to the data factory resource and make sure actually they're all there. Hopefully we can see all our data factories here. So as you can see, we've got the dev data factory, prod, and the test data factories, and they're all associated with their resource groups as well. So that's the end of this lesson. I'll see you in the next one. Now that we've created the data factory resources, in this lesson we're going to configure a Git repository to our development data factory. Before we go ahead and do that, I want to quickly walk you through a couple of area-specific terminologies around Git branches so that it'll be easier to understand the implementation. We went through this diagram previously, but let's go a bit deeper. As you're probably aware, there are many branching strategies you can follow to work with Git. The one you're seeing in the screen is what Microsoft documentation recommends for ADF developments, and also the one I've seen working well. So this is the one we're going to implement. As you can see, master or the main branch is the only one from which you can publish to the ADF repository. Data Factory calls this as the collaboration branch. No direct development should be allowed in the master branch. Instead, developers will create feature branches to do the development work, and that's merged to the master branch via a pull request. Once you publish the code from the master branch, that creates the ADF publish branch with the ORG template. I'll talk you through the development process in detail in the next lesson, but this is all we need to know to configure the Git repository. So let's get started. Here we are in Azure DevOps. The first thing we want to do is to create the Git repository. Just so you're aware, you can either create the Git repository in Azure DevOps and then go and configure the data factory to use the Git repository, or you can even use the data factory to create the Git repository first. But I like to do it this way so that I can create the repository, I can set the branching policies before I get data factory to access the Git repository. So we're going to do it that way. So in order to create the Git repository, you click on the project, and then you can come to the repos, and this is where you can create the repos. As we said before, we already have a repository called Azure Data Factory CACD with the same name as our project. That's created by default. So in order to create a new repository, you just click on the new repository and then give a name for the repository. I'm going to name my repository with the same name as my data factory so that it's easier to find it. So let me go and find the data factory name. So that's our dev data factory. Let me copy the name of the dev data factory, and then I'll use the name here, and let's click create. So we now have the repository. If you click on the drop down here, you can see two repositories, and we are on the new repository that we created. Let's now look at the branches. So come over to the left hand side and click on the menu here for branches, and that shows you the branches in this repository. So in our case, we only have the default branch, which is the main branch. So depending on how you created your repository, your branch might be called main or master. Generally, if you use DevOps to do that, then you will get the main branch as the default branch. But if you did it via data factory, you might see master as the default branch. But it's basically the same. So you've got your default branch, which is your collaboration branch. As we said before, we wouldn't want to allow any development to happen directly on the main branch. We want the developers to create feature branches and then merge to main via pull request. So we need to set a branch policy on our main branch. So in order to do that, you come over to the right hand side and click on the three dots here and click on branch policies. And that brings up the branch policies here. You can set a lot of options, but the one we are interested in is the top one here, which is to say that it requires a minimum number of reviews and you can only merge it via a pull request. So turn that on, and by default it's asking us to have at least 2 reviews. That's probably what you want for your project, but here I'm the only one on this Active Directory, so I'm going to just say 1 review so I can approve it. And also I'm going to tick on allow requesters to approve their own changes. This is not something you would want to do in your teams because you don't want to be approving your own changes. You would want someone else to review your changes. But in our case here, we are the only user on this Active Directory, so I'm going to just let me be able to review my own changes. So with that, we've created the Git repository and also we've set the branch policy. So the next thing to do is to go to the data factory and configure Git. So in order to do that, I'm coming over to data factories and open the data factory studio for our dev data factory. And you've got a couple of options. So the first thing is actually, as you can see here, it already says that you can set up code repository from here, or you can go to author and then you can just click on the drop down here. By default, it's on the live mode and it's using data factory as the repository. Instead, you can set up code repository, or you can come over to manage and then click on Git configuration and then click on configure. So everything brings up the same dialog box as you can see here. And let's pick the repository type. In our case, as we said, we're using the Azure DevOps Git. So select that one, and we need to pick the Azure Active Directory. We know that our Active Directory is the default directory, so let's just use that one and then click continue. And now we need to pick the DevOps organization name, so I call that as my name. So let's select that one. And we need the project name, so I've only got one project, which is the Azure Data Factory CI/CD. Let's select that. And we need the repository name. Here, you will be able to type in a repository name if you wanted. So if you didn't have a repository, you just type that in, and that gets automatically created in Azure DevOps. But in our case, as we know, we just created a repository, so let's pick that. So click on the drop down, and that will show you the repository is already available. The one that we created for the ADF work is the dev CI/CD demo ADF. So let's pick that. And this is where we need to specify the collaboration branch. So we have the main branch as the collaboration branch. If you wanted to use something else, you can create a new one as well. But we're going to use main as our collaboration branch. And the next thing is publish branch. You can't change this one. You will have to use the ADF publish branch. We know what ADF publish branch is going to contain, which is the ORM templates. We talked about that already. And here you've got the option to specify whether you want to have all your data factory asserts in a separate folder, or you want to have that in the root folder itself. So if you want to give a folder, you can do that. I'm going to just leave that as blank. And you also have the option to import any existing resources. So for example, you created a lot of pipelines within your data factory without enabling Git, and you want to bring them into Git now. You just take that to import everything into Git, and you work from there. But we don't have anything, so we cannot take that. Let's click apply, and that should configure our data factory with Git. So as you can see here, the repo has been connected, and it's using working branch as main. But as you can see here, there is an error because we've got a working branch as main, but we've configured such a way that actually we can't apply directly changes to the main branch. That's why you're seeing that error. But that's okay. When we come to do our development, we'll be using feature branches to do the development. So let's go over to author. And now we'll be seeing everything which is on the main branch. So we've now successfully integrated our data factory with a Git repository. And that's the end of this lesson. I'll see you in the next one. Now that we've configured the data factory to use Git as a code repository, let's go through the development process using this approach. Let's assume that we have a new feature to be added to our project, and that just requires us to develop one pipeline with a simple wait activity. The first thing we need to do is to create a feature branch. We then can start developing the pipeline in the feature branch, and we can save the code as we go along. ADF will treat each of the saves to the pipeline as commits to the Git repository. We can then debug the pipeline, and once we are happy with the results, we need to create a pull request so that the code could be sent for review. The reviewer then reviews the changes and approves or rejects the pull request. If approved, the code could be merged to the collaboration branch, which is the main branch in this case. That's the process for developing code. With this approach, multiple developers can create their own feature branches and work on their assigned pieces of work, carry out reviews, merge changes, etc. One thing to note here is that the feature branches and the pull requests can be created either directly in Azure DevOps as well as in the Data Factory UI. I tend to use Data Factory UI where possible, and I would encourage you to do the same. Hope you now have a good understanding about the code development process for Git-enabled data factories. Let's put this into practice to strengthen your understanding. Here we are in our dev data factory. As you can see here, we are currently connected to the main branch, but we need to create a feature branch to develop our code. In order to do that, click on the drop down here and click on new branch and give a name for your branch. I tend to keep all my feature branch under a folder called feature, so I'm going to go for feature slash, and then you need to give a name for the branch. You want to give a meaningful name generally, but I'm going to go for feature underscore one just to keep it simple. And make sure that actually you have selected main branch as the based on, because our feature branch is going to be based on the main branch. So it takes everything from the main branch and creates the feature branch for you. So click create here, and that will create the feature branch for us. That's now created, and as you can see here, we're also connected to our feature branch. So if you click on the drop down here, you will see all the branches available. So we got the main branch and the feature branch here. So this branch will also be created in our DevOps repo. Let me show you that. So I've got my DevOps repo here, and if I click on the drop down here, I'll be able to see all the branches. I'm not seeing the feature branch, that's because I haven't refreshed it. So let me quickly refresh this. And now if I click on the drop down here, I'll be able to see the feature branches. So that's one way of seeing your branches. As you can see, I've got feature slash feature one, or you can simply click on branches and then you'll be able to see the branches. So as you can see here, because I did feature slash feature one, it's grouped into a folder called feature. So now let's switch back to our data factory and start developing the pipeline. So as we said, we want to create a simple pipeline with a wait activity. So let me click on pipelines and then click new pipeline. And let me give it a name. I'm going to give it again a simple name, say call it PL underscore pipeline one. And we wanted to bring in a wait activity, and I'm going to just bring that one in, and I'm not going to make any other changes. So we now have the pipeline ready. You can click on the debug. As you can see here, debug button is enabled, so you can click on the debug button and then just debug the pipeline here. As you can see, the pipeline has succeeded. It's just a simple pipeline which waits for a second and carries on. That's what's happened here. But now we need to save the changes. In the past, we always save the changes to our repository by clicking the publish button here. But as you can see here, the publish button is grayed out. As we discussed before, publish is only available from the collaboration branch, which is the main branch in our case. Otherwise, we'll have to just save the changes to our Git repository. In order to save the changes to our Git repository, you've got a couple of options. You've got a save button here, which will save just this pipeline, or you can do a save all, which will save all the open tabs. So I'm going to just click simply on save all. And now the changes are successfully saved to Git. So let me show you in Git repository how the changes look like. So if you go over to files, now we're connected to main, so we got no other files here. But if you switch to the feature branch, that's what we created, you will see a new folder called pipeline. So within the pipeline, we've got the JSON file for the pipeline. As you can see here, it just has one activity called wait one, which is of type wait. So this is basically our code for our ADF pipeline. If you had datasets, link services, and triggers, you'll have separate folders, and they'll all be listed here. But for all of those objects, Data Factory always creates a JSON object behind the scenes, and that is basically our code. With that, we've successfully created our feature, which is just a pipeline, and we've also debugged the pipeline to ensure that it runs. So the next thing we want to do is to create a pull request so that the changes can be reviewed by someone, and also it could be merged into the main branch. So in order to create a pull request, you can either click on the create pull request button here, or you can create a pull request from Data Factory. And as I said before, I generally tend to do it from Data Factory. So come over to Data Factory and make sure you're connected to the feature branch, and then click on the drop down and select create pull request from the menu. And that opens up this form within Azure DevOps again. As you can see here, this is Azure DevOps, and you fill in the details. I'm going to give it a meaningful title, and also add a meaningful description and give as much information as you can for the reviewer to understand what you're trying to get reviewed. And we need to select the reviewer. In our case, actually, we need at least one reviewer, we said, but the reviewer can be myself, so I'm going to just simply put my details in there. So that is the aza.adm account. And let me click create, and that will create the pull request. So I get an email to say that actually I've been asked to do a review, and also as you can see here, you can see all the pull requests here. I just want to reiterate that I'm reviewing my own changes here, but if you are in a team, normally you won't be reviewing your own changes and somebody else will be reviewing the changes. So once you get your pull request, you will look at the changes. So in order to see the changes, you can go to files, and if there are changes, then you'll see the old code and the new code, but here it's just a new piece of code. So I've been asked to review this change, which is just a new pipeline. So when I look at it, everything looks okay, so I'm just going to click on approve. So when you click approve, it'll just approve that. You can see the actions in overview tab. So as you can see here, one reviewer approved the changes. So now the changes have been approved within the feature branch. The next thing we want to do is to merge the changes to main. In order to merge the changes, you just have to complete the pull request. So let me click on complete, and you select the merge type. Let's keep it simple and go for the standard merge, no fast forward. And you can do a couple of things. If you had a work item associated with this, you can complete that work item. In our case, actually, we didn't go to Azure Boards at all to do anything, so there's no work items, but I'll still leave that as ticked. And you can also request for the feature branch to be deleted after merging. So I generally tend to tick this so that the feature branches are deleted and we're not having too many feature branches hanging within DevOps. So if you are not likely to go back and make changes in the feature branch again, just tick that and then delete the feature branch, and you can create a new one when you have a bug or hotfix or anything to apply. So let me click on complete merge. And as you can see, the merge has now completed. So you will be able to see the new pipeline within our main branch as well. So let's see that first in DevOps, and then I'll show you in Data Factory. So you come over to branches. As you can see here, we only have the main branch now because we asked for the feature branch to be deleted. So click on the main branch, and as you can see, within the main branch, we've got the pipeline folder with a new pipeline as well. So all of the code changes from our feature branch have been merged into our main branch. In our case, it's just a simple creation of a new file. Let's go over to the Data Factory, and let me show you the main branch here as well. So if you try and refresh it now, it'll give you an error because we're connected to the feature branch and the branch no longer exists. So let's try that anyway. So as you can see, please set a working branch because the feature branch is no longer available. So let's pick the main branch as our working branch and click save. And as you can see here, we've got the pipeline within our main branch. So that's the development process for working on a Data Factory which is integrated with Git. If you want to make a code change to this pipeline, you'll follow the same process. So let's say we've got another feature which is asking us to make a change to this pipeline, and I'll take you through that again. But if you want to do it yourself, please go ahead and do it. And I'm going to just simply click on this drop down and click on new branch and give a name for this branch. And let's click create. So we've got a feature branch now, so we are connected to the feature branch. And let's click on the pipeline, and I'm simply going to change the pipeline from waiting for 1 second to say 5 seconds. And I'm going to quickly debug the pipeline, so I've clicked debug, and that's going to just run through. And as you can see, that's succeeded now. It took 6 seconds instead of 2 seconds for the first one. That's because we waited for 5 seconds within this wait activity. And we are simply going to click on save to save the changes to Azure repo. So every time we click save, what that does is behind the scenes, it commits the changes to our Git repository. So let me show you that. If you go over to Azure repos and click on commits, you will see the commits. So as you can see here, the last commit is here, which is updating that pipeline. And if I click on that, I'll see the changes. So we've gone from wait of 1 second to 5 seconds here. So it's exactly the same as you working with any other tools to interact with Git. In this case, we're using Data Factory's UI to do that. So now that we've done the change that we wanted to make, let's create a pull request to merge the change. I'm going to go over to the drop down here and then click on create pull request. And I'm going to just give it a title, and let me pick the reviewer. That's again myself, and I'm going to click create. That's created the pull request. So let's have a look at the changes so that we can approve or reject based on whether the changes are as we expected. As you can see here, this time it showed us actually what's being removed and what's being added within that file, which is the PL pipeline 1.json, and the changes are as we expected. So we can simply click approve, and we can click on complete to merge the changes. So I'm going to again delete the feature branch because we don't need that anymore, and let me click on complete merge, and that should merge the pull request for us. And if I go over to the Data Factory, that branch will be now deleted. So let me switch to the main branch, and we should see the change in main branch as well. And as you can see here, we've got the wait time in seconds set to 5 instead of 1 now. So that's the development process you would follow to work with the Data Factory, which has been configured to work with Git. So that's the end of this lesson. I'll see you in the next one. Now that we've completed the development of the pipeline, in this lesson, I'm going to take you through the build process using option 1, which is using ADF publish. In order to publish the code, we simply have to switch to the collaboration branch, which is the main branch in our case, and click the publish button. This will publish the changes to our dev Data Factory repository. Also, it creates the ARM templates in the ADF publish branch. Let's switch over to the Data Factory Studio, and I'll demonstrate this. Here we are in our Azure Data Factory Studio. As you can see here, we are connected to our Git repository on the main branch, and also we can see the pipeline that we've created. And the important thing to notice here is that we've got the publish button being enabled here. You may remember that when we were in our feature branches, the publish button was grayed out. Because our main branch is the collaboration branch, the publish button is enabled. We simply have to click on the publish button in order to publish the changes into our ADF repository as well as the Git repository. But before we do that, I want to show you the state of those repositories. So let me first go to the ADF repository. In order to do that, you click on the drop down here and switch to live mode. And as you can see here, there are no pipelines, no data sets, nothing. It's an empty repository at the moment because we haven't published anything yet. So let me put back on the Git repository here, which is on the main branch. And also let's go over to Azure DevOps and have a look at the branches here. As you can see here, we only have the main branch. There is no ADF publish branch. That ADF publish branch gets created first time when you publish something to this repository. So let's now go over to the Data Factory and click on the publish and see all of that in action. And it's now gathering the changes. And as you can see, we only have a new pipeline, which is PL pipeline 1. That's all we've created. So let me click OK. And that's now deploying that resource into our ADF repository. And that's now been completed. And also it will create the ARM templates for us. So as you can see, it's generating the ARM templates at the moment and it's saving them in Git. So all of that has happened. There is nothing more to go here. And let's now first switch to our ADF repository and see. As you can see here, the pipeline has now been published here. So the pipeline is also available in our ADF repository. And the other thing we want to see is the ADF publish branch within the Git repository. So let's go over to DevOps and let me do a refresh. And as you can see here, we've now got a new branch called ADF Publish. And if I click on that, we'll be able to see the files. And it's got a folder with the same name as the Data Factory. And within that, we've got the ARM templates. So you've got the ORM template here. So this is the ORM template. This is simply a JSON file, and as you can see here, it's got all the information about our data factory. So that includes the data factory name, the pipeline name, the activities within the pipeline, and all of that information. And also that it is normally accompanied by a parameters file, and the parameter has got the factory name with the value of dev CICD demo area. So the purpose of the parameter file is that you can change the value of the parameter while you're deploying to other environments. So when we go to test and production, we're going to have different names for our data factories. So we simply have to change the name of the parameters and then just deploy them into those environments. So that's the purpose of that. So these are the two on files within this branch. So now we publish the changes to both Git repository as well as to the ADF repository. So that's the end of this lesson. And welcome back. Now that we've completed the continuous integration for CI/CD, let's turn our attention to continuous delivery. The input to this process is the ORM template in ADF publish branch from the build process. We simply need a release pipeline which will deploy the ORM template to the test and production data factories. Having said that, it is unlikely that you will see a release pipeline which deploys to both test and production data factories at the same time. What we generally see is a release pipeline which deploys to a test data factory and only attempts to deploy to production factory after a successful deployment to test. Again, even though companies like Netflix does automated test and continuous deployment to production in this manner, most projects follow a manual approval process before deploying to production. So a release pipeline would look more like this with the manual approval process. This is the kind of solution we are going to implement in this course. In summary, we'll have a release pipeline which deploys the ORM template to the test data factory, and on successful completion of the deployment, it sends an approval request for a deployment to production. Once the request has been approved, the release pipeline then deploys the ORM template to production. Now that we understand the high-level design for the release pipeline, let's take a look at the jobs the release pipeline may contain. We have the ORM template which needs to be deployed to the test data factory. Azure DevOps provides a job called ORM deployment. We can simply invoke the job with the required information about the ORM template and the data factory details to perform this deployment. Unfortunately, this deployment comes with a couple of issues. Firstly, the deployment via ORM template deployment can only add or update artifacts. It doesn't delete any components. For example, if you deleted a pipeline, that won't take effect. Also, the deployment fails if we try to update a data factory trigger which is currently active in the test data factory in this case. So Microsoft Azure team have provided us with a deployment script which will stop the triggers before the deployment and start them once the deployment completes. Also, it tidies up the deleted objects. The script is written in PowerShell, so we need a pre-deployment PowerShell job as well as a post-deployment PowerShell job. That will complete the release pipeline for test area. But we also have to deploy to production. In order to do that, we can keep all the jobs for deploying to test in a stage called test, and we can then create another stage in the release pipeline to deploy to production. The only difference is that the production stage will require an approval, and it waits for the test deployment to complete. Basically, we'll have a release pipeline which will use the ORM template as the source artifact, and it contains two stages, one for test and one for production, and each of them will have three jobs that we talked about. I'll take you through the process of creating this pipeline in the next few lessons. Now that we have a detailed design for our release pipeline, let's start creating it in Azure DevOps. Instead of creating the entire pipeline in one attempt, in this lesson, we are going to start creating a simple release pipeline which deploys the ORM template to the test data factory using the ORM deployment job. Let's switch over to DevOps and get started. Here we are in Azure DevOps. Let's click on the project. And in order to create a pipeline, you come over to pipelines here on the left-hand side menu and then select releases because we are creating a release pipeline which is for our continuous delivery. So let's click on releases, and from here you can click on new pipeline to create a new release pipeline. As you can see here, DevOps offers a number of templates to speed up the creation of the release pipeline, but we're going to simply click on empty job and start everything from scratch. As you can see here, it's got two sections, one called artifacts and another one called stages. So artifacts is basically the input or the source information we need for our pipeline. In our case, we want the ORM template from our ADF publish branch in the Azure DevOps repo. So that'll be our artifact, and we're going to have two stages, one called test and one called production. But for this lesson, we're going to just focus on test, and then in the next lesson, we'll copy that to create the production stage. So let's call this one as test. Let's now add the artifact. In order to do that, come and click on the box here, and that gives you the option to pick different sources like a build pipeline, Azure repos, Git, GitHub, etc. But in our case, as you remember, we don't have a build pipeline because our build is manual build, but we've got the ORM templates within our Azure repos. So let's click on Azure repos, Git, and let's pick the project. In our case, it is Azure Data Factory CI/CD, and we want the repository name. So we've got the repository specific for the data factory, which is the dev CI/CD demo ADF, and let's pick that one. And we need the branch name. So in our case, we know that the ADF publish branch is the one which has got the ORM templates. And from there, we want to get the latest from the ADF publish branch. So it is all the latest ORM templates which arrives there rather than from specific commits. So let's pick latest from default branch, and that's everything. So you can rename the source alias if you wanted to, but I'm going to leave it as it is. And let's click add. So with that, we've added the artifact. Now we can use the artifact within our tasks. So as we discussed before, we got the stage which is test. Within the stage test, we can add our tasks. We want to add the first task, which is our ORM deployment, and in the future lessons we'll be adding the pre and the post deployment scripts as well. So in order to add the task, either you can click on the hyperlink here, or you can come over to tasks here and then add the task. But I'm going to go back to pipeline and click on the hyperlink here, and that brings you to the same place where we came previously. And to add a task, you click on the plus button here. So it lists the tasks which are available within DevOps, but we know that we want to pick a task called ORM template deployment. So let me search for ORM, and as you can see, we've got a task called ORM template deployment. That's the one we want. So let's click add here. So that's now been added, but as you can see here, it needs some settings. So let's click on the task and add the information. The first thing we've got there is task version. We always want to pick the latest version, which is 3.3.star at this point in time. And let's give a display name. We want to give some meaningful name. So that's the ORM template for our ADF deployment. The next thing we want to specify is the deployment scope. We're going to target our deployment to resource group rather than to the entire subscription or the management group. So let's select the resource group. So the next thing we want to specify is the resource manager connection. We don't have a connection at the moment. Let me click on the drop down and show you. As you can see here, we don't have any connections under the available Azure service connections, but we can create one. So in order to create a connection, click on the subscription that you've got, and then you got two options. One is to click on authorize. What it does is when you click on authorize, it will create a new service principal and assign contributor access on the subscription to the service principal. So that means the service principal and this resource manager connection is going to have full contributor access on your entire subscription. If you're in a production scenario, you wouldn't want to do that, but if you want to keep it simple for this exercise, please click on authorize and carry on. But in a production scenario, you would want to restrict access to only specific resource groups. You wouldn't want to give it to the entire subscription. Let me show you how to do that. In order to only give access to certain resource groups, you just click on the drop down here and click on advanced options. And now you got the option to select the resource group to which you want to give the contributor access. Make sure that you've selected the service principal authentication and click on the drop down. In this case, we want to give access to our test resource group. That's where our test data factory is. So it is test CICD demo org. That's where our data factory is, and that's the one we are going to give contributor access to. So let me explain that one more time. So this is going to create a new service principal, and the new service principal is going to have contributor role within the resource group test CICD demo org. So that means our pipeline will be able to deploy the OM template into that resource group. So let me click OK. The resource manager connection has now been successfully created. Let me show you that. If you click on the drop down here, you will see a connection. As you can see here, we've got a connection assigned to our subscription. As I said before, it also creates a service principal, but the service principal will have a random name. When I say random, actually, it comes up with its own name, which normally is your organization name. As you can see here, my organization name is Ramesh Ranaswamy, and then it concatenates the project name, which is the Azure Data Factory CI/CD, and also it concatenates the hex value of my subscription here, and a service principal is created, and that service principal will have contributor access on my resource group. So let me show you that as well, so that you've got full understanding. So let me switch over to Azure Portal, and let's go over to resource groups, and let's search for the resource group, which is our test resource group, because that's the one we gave access to. And let me click on that. And if I go to access control and IAM, and if you go to role assignments, as you can see, we've got a role contributor role assigned to this service principal. As I said before, this service principal has got the name, which is my org name for the DevOps, which is Ramesh Ranaswamy - Azure Data Studio CI/CD, and then the rest will be the hex value of the subscription, as you can see here. So in essence, what we have done is we've created a resource connection and a service principal, and we've given it just the required access to this resource group, so it doesn't have access to anything else. That's kind of what you would need in a production environment, because you wouldn't want to give access to the entire subscription. Okay, let me go back to the DevOps pipeline now, and let's carry on with filling the details for the rest of the information. The next thing we need is the subscription, which is my pay-as-you-go subscription, and the next one we want to specify is action. The default is create or update a resource group, and the other one you've got is delete a resource group. Here, we don't want to delete this resource group, we want to create or update the resource group. In this case, basically, we already have the resource group. We're going to apply this OM template as an update to the resource group. So let's click on create or update resource group, and we want to specify the resource group. Let's pick this resource group, and that's going to be test CICD demo org, and we want to specify the location where the resource group is. In my case, as you know, that is in UK South, so let me just pick that. And now we need to specify the OM template information. So you get two options for the template location. One is the linked artifact or the URL of the file. In our case, we just created the artifact with the source as our Azure DevOps repo, so we're going to use linked artifact. And we need to specify the template and the template parameters file on these two sections. I'm going to click on the three dots here and browse to the template, and it will give you all the items in our linked artifact. Because we've already created the artifact, we can pick the OM template from here. Just scroll down to the folder dev CICD demo ADF, and within that, we've got the OM template. So make sure you're selecting the template rather than the parameters file, because the parameter file goes in the next box. So let me pick the parameters file now. This box lets you override any template parameters if you have. We do have a parameter in our template, so let me show you that first, and then we can override it. So in order to do that, I'm going to go to DevOps, and I'm going to go to the repos and show you the file. So we're on the ADF publish branch, and I want to go to the OM template parameters. And as you can see here, we've got a parameter called factory name, and the value is set to dev CICD demo ADF. We don't want to deploy to dev ADF, we want to deploy to test ADF. So we need to override this value to have the test data factory name rather than the dev data factory name. So that's what we're going to do. In order to do that, you come over to the release pipeline again and click on the three dots, and you can change the value here. As you can see, we've got the parameter name as factory name and the value as dev data factory name. So let's simply change that to test. And let's click on OK. And at this point, I want to tell you one thing, which is actually we have hard-coded the data factory name here. We've also got the resource group name hard-coded and the location and things like that. But we can use variables for these things. So as you can see here, we got a section to define our variables. And the advantage of defining a variable is that once you've done that, when you want to copy the same pipeline for another environment, you don't have to change the pipeline, you just have to change the variable values. So that's what we will be doing, because we're going to go to test and then we're going to go to production. But just to keep it simple, I'm just hard-coding the values here. Let's now talk about the deployment mode. The default is incremental, and that's what we want to specify. The other options you've got are complete and validation. I would like you to understand all of them really clearly, because it's very important, otherwise you could do damage to your resources. So incremental is where it takes the objects or the resources from the OM template and updates them within the resource group. So in this case, it will take the information about the data factory and updates the resource group with the data factory information. It doesn't do anything else. But if you specify complete, it will delete every resource within the resource group and applies the OM template to that resource group. So imagine if you had other resources within this resource group. For example, you had a data lake and also you had a key vault. What would happen is it would delete the key vault, the data lake, as well as the data factory. But the OM template only has information about the data factory. So it will just apply the data factory, and you would lose the data lake and the key vault. So you wouldn't want to do that. So please be careful. Validation just looks to see whether the OM template has got the right information and there are no syntax errors and things like that. So let's select incremental, and you can specify deployment names and things like that. We don't need to worry about that. So that's everything we want to specify for the OM template deployment task. And as I said, we can use variables for some of the things, but we're going to go ahead with the hard-coded values for now. So let me go back to the pipeline, and as you can see, we've got the artifact and we've got the stages, which is test. One more thing we want to do is, at the moment, this pipeline is not going to execute. So you can manually run the pipeline if you wanted to, but we don't want to do a manual run. We want to have continuous deployment. As soon as there is a new update to our ADF publish branch, we want to run this release pipeline so that it releases our test data factory. To enable that, you come over to the trigger button here and click on this button to enable it, and now add the filter to include the ADF publish branch. So that's all you need to do. So now we've enabled continuous deployment for our pipeline as well. Let's now give it a meaningful name, and let's save the changes. So I'm going to click on save. I'm going to give a detailed comment, and let's click OK. So all the changes have now been saved, and that's the end of this lesson. In the next lesson, we'll look at how to run this pipeline. now that we created our release pipeline, let's think about testing. As you know, we've enabled continuous deployment for our pipeline here. So when you publish a change to our data factory, that will automatically trigger this pipeline, and that should get deployed to our test data factory. That's one way of testing, but you can also create a manual release by clicking the button here, and that will deploy everything from the dev data factory as it is at the moment to our test data factory. So that's what we're going to do first. So we're going to create a manual release and make sure what's in our dev data factory gets deployed to test data factory. But before we do that, let's look at the dev and the test data factory and see what should get deployed. As you can see here, on the dev data factory, we've already created a pipeline called PL Pipeline 1, and that's all we've got on this dev data factory. And in our test data factory, we've got nothing. It's an empty data factory. So we should see that pipeline deployed in our test data factory once the release has gone through successfully. So let's try that. So I'm going to go to DevOps and click on Create Release, and let's click Create. So that'll create a release. As you can see, it says a release has been created. So I'm going to click on this hyperlink here, and that'll show us all the releases. And I'm going to close this information here. And as you can see, it's running at the moment. So it's done the artifacts and it's on the test stage. So in order to see the logs when it's running, you can just hover over here and click on logs. That's what I'm doing. As you can see here, it's downloaded the artifacts and it's now doing the template deployment. So as you can see here, the template deployment's now succeeded and the job's totally succeeded as well. So let's click on that. Make sure there are no errors. As you can see here, it's a clean deployment. So let me close that and go over to the test data factory and refresh the data factory to see whether the pipeline's copied. As you can see, it says there is one pipeline and we can see the pipeline here. So we've now successfully deployed the ARM template from our dev data factory into test data factory. That's one testing out of the way. Let's do the next one, which is to do the continuous deployment. In order to do that, we'll have to make a change to our dev data factory and publish that change so that it gets deployed to test as well. By now, I hope you're familiar with the development process for a Git-enabled data factory. So as you know, we'll have to create a feature branch first. So I'm going to click on the new branch and create a feature branch. And now I'm going to create another pipeline here. So I'm going to click on new pipeline and let me give a name for this pipeline. And again, let's keep it simple and let's bring in a wait activity, and I'm going to just save everything. So we don't need to debug it because we know it works. It's just a wait activity here. So that's been saved to our Git repository. The next step is to create a pull request. So I'm going to click on create pull request here, and I'd encourage you to give meaningful titles and description, but for now we can just keep them as they are, and I'm going to assign it to me. So that's going to go to me for approval, and let's click create. And because I am approving my own changes, as you know, I'm going to simply click approve here and also complete the pull request, and I'm going to use the merge, which is the default option here. And let's click complete merge. And as you can see, it's now merging the pull request. But once the pull request is merged, which has happened already, we can go over to our data factory and publish the changes. As you know, the pull request has merged the changes from the feature branch to our main branch. So let's go over to our data factory. And now let's switch to our main branch. So we're on the main branch, we can see both pipelines here. And let's click on publish. So now the publish is happening. So as you can see, it's detected a new pipeline, and that's everything we did. So let's click on OK. And that should now deploy to our dev data factory as well as create the ADF publish branch. So publishing is now completed, and the next step is it will create the ARM template. So it's generating the ARM templates now. So let's now go over to the Azure repo, and we should be able to see the branch being updated. So as you can see, the ADF publish branch has been updated just now as well. So if we go over to our DevOps release pipeline, so I'm going to go to pipelines and releases, we should see another release. As you can see here, the second release has happened. It's happened really quickly. So it's 15:59 now, and 15:58:57, the release has finished. So basically what happened is we made the change in our dev data factory, and that triggered this pipeline to run because it's part of the continuous deployment. And let's go into the pipeline, make sure it's okay. So as you can see, it succeeded. But if you want to see the logs, you can click on the logs and make sure all the tasks have succeeded as well. And here we have only one task from our side, and that succeeded as well. So now we should be able to see that pipeline in our test data factory. So let me go over to the test data factory. As you can see, we've only got one pipeline, but when I refresh, I should see the second pipeline as well. So as you can see, we've got two pipelines now. We've successfully completed the testing of our release pipeline to ensure that it's doing continuous deployment. Pipeline doesn't handle deletes to the data factory objects. For example, if you deleted a pipeline from the dev data factory, that won't be applied as part of the deployment to the test or production data factories. Secondly, we cannot update an active trigger as part of the deployment. An update to an active trigger will result in failure during deployment. These are the two issues, and we need to fix them. But the rest of the lesson will be focused on demonstrating these issues so that we can see the effect when it's fixed. Please feel free to skip this lesson if you're just keen on the solution and not interested in seeing the problem. For the rest of you, let's switch over to the data factory and get started. Here we are in the development data factory. We're going to create two releases. The first one to demonstrate that the deletion to the objects are not working, and the second one to demonstrate the update to the triggers, active triggers, is not working. But in order to show that the update to the active trigger is not working, we need to have a trigger in place. So as part of the release one, we'll also create a trigger so that we can go and update it in the second release. So let's create a feature branch to get started. I'm going to click on the new branch and then give a name for the branch. And now we want to delete one of the pipelines. Let's say we want to delete the pipeline 2. So I'm going to just simply click here and delete the pipeline. And we also need to create a trigger so that we can update the trigger in the next release. So as you know, we need to go to Manage Hub and then click on Triggers and click New to create a trigger. I'm going to call that one as trigger_1. And let's go for a tumbling window trigger. And we can start it from now. And let's say we want to run it every day. So that'll be 24 hours. And we're not going to specify the end date. We're going to specify the end date in the second release. So I'm going to click on Start Trigger on Creation as well. And let's click OK. So now the trigger has started, but we want to attach that to the pipeline as well. So let's go to the pipeline and let's add the trigger to the pipeline. I'm going to go to New Edit here and attach the trigger to the pipeline as well. And let's click OK. But it says actually you need to publish the trigger to be activated, but we can just save it here and we can publish it later. So that's now been saved. Let me show you the trigger one more time. So as you can see here, the trigger is here with the status of started. So we now simply need to create a pull request so that the feature branch can be merged to the main branch. So I'm going to click on Create Pull Request, and that's opened up this form. Let me key in the details I need. And I'm going to add myself as the reviewer again, and let's click create. And that's created the pull request, and because I'm the reviewer, I'm going to simply click here and approve it. And also, as you know, we're going to do the merge, so that means it's going to be merged to the master branch. I should have showed you this before, but let's see the changes we made here. So if I go to the files, I'll see the changes. As you can see, we've deleted this pipeline and we've added this trigger. That's what we're seeing here. So everything looks okay, and the pull request has now completed. The next thing we want to do is to publish the changes to data factory so that our ADF publish branch gets updated with the ORM template. So let's go over to the data factory and switch to the master branch or the main branch. And we should only see one pipeline as we're seeing. And let's click on publish. And that's detected the changes. As you can see, it's deleted the pipeline and it's adding a new trigger. So let's click OK now. And the publishing is completed and it's generating the ORM templates. So let's go over to our release pipelines and see whether that's started running. So as you can see, that's now started going. So that's our release 3 and it's being queued at the moment. So that's in progress, and let's click on the logs and let's see what's happening. Hopefully we don't get any errors. And the deployment has now successfully completed. So let's go over to the test data factory and have a look to see what's happened. So I'm here in the test data factory and let me click on the author tab. As you can see, we've got the 2 pipelines and we don't have any triggers. Let me go over to triggers. There are nothing in here. When I click on refresh, we should see one of the pipelines disappearing from here and the trigger appearing. So let me click on refresh. As you can see, that hasn't happened. We still have the 2 pipelines. That's because the ORM template deployment doesn't delete any existing objects, but we should see the trigger. So let me go over to manage and we've got the trigger. One thing you want to know is that whenever you deploy a trigger that doesn't get automatically started, you'll have to manually come in and start the trigger. So that's what I'm going to do. I'm going to click on start and the trigger is now started, and let me publish that to the data factory in test as well. So that's now happened. So just to recap, we've now demonstrated that the deletion of the pipeline hasn't happened, and also we have deployed the trigger into our test data factory. So the next thing we want to do is to go and update this trigger in dev data factory and see whether that gets applied or whether we get a failure. But we know that it's going to be a failure. So let's go over to our dev data factory. We're simply going to update this trigger to put an end date. But in order to do that, as you know, we need to create a feature branch. We could have left the branch from the last time because we knew we were going to come back and do an update, but I have deleted it, so I may as well just create a new branch. So I'm going to create a new branch now. And let's make the changes in this branch. So I'm going to click on the trigger and I'm going to simply update with the end date. So I'm going to go for tomorrow's date and let me click OK and click OK. And as you can see, it's been updated and it's still in the starter state. One thing you may have noticed is that the trigger is automatically saved. We didn't click on the save button here and it was automatically saved. So that's the feature within Data Factory. Let me show you in the notifications. And as you can see here, the trigger has been saved. So now we need to create a pull request and merge the changes. So I'm going to click on create pull request and that says updating trigger. I'm going to leave it as it is and let me assign it to myself and do everything we normally do. And let's approve the changes and complete the pull request. And I'm going to complete the merge. So the merge is now completed. Let's go over to Data Factory and let's go to the main branch and publish the changes. So I'm on the main branch now. So let me click on publish and that should publish the changes. So that's done now. So let me go over to the release pipeline and see what's happening. So as you can see, we've got the 4th release pipeline now created and we expect this one to fail. So as you can see here, we've got a failure here and it says you cannot update enable trigger. The trigger needs to be disabled first. So with that, we've successfully demonstrated our second issue as well, which is when we try to update an enable trigger or a started trigger, we get a failure. So we need to fix these 2 issues. So that's what we'll be looking at in the next lesson. Now that we understand the issues faced by the current pipeline, let's look at fixing them. As we discussed before, in order to fix these issues, we need a pre-deployment script to stop the active triggers and a post-deployment script to start the triggers after the deployment. Also, we want the post-deployment script to delete any objects that are not present in the ORM template. We can write our own partial scripts for this, but Microsoft's made a script available in their official Git repository, and we can use that. Let's start by taking a look at the Microsoft documentation around this. Here's the documentation for the pre- and the post-deployment scripts, and this is the URL which will get you to the documentation. I'm going to leave a link for this documentation in the course resources for you, but let's quickly walk you through the documentation. As you can see here, there's a link which will take you to the GitHub repository which has the partial script. Let me open that app. And as you can see here, there are 2 versions of the script. So there is a pre-post deployment script.ps1 and a version 2.ps1. The difference between these 2 scripts is that the version 2 is a bit more efficient because version 1 turns off and on every trigger, immaterial of whether that's been changed. But version 2 only turns off the triggers which have been updated in dev and we are trying to deploy. So that's a bit more efficient. So I would encourage you to use version 2. Now let's switch back to the documentation. There's a note here about the information I just talked to you about turning off and on triggers. You can read that through, but let's have a look at the execution and the parameters. As you can see here, the partial script takes a few parameters. This is when you're running it as a pre-deployment script. So when you do that, you pass in the ORM template location and you specify the resource group name, data factory name, as well as a flag to indicate that it is a pre-deployment and a flag to indicate that we don't need to delete the deployment details from ORM. And when you're running it as a post-deployment script, again, you specify the ORM template location, resource group, and the data factory name, but this time you specify that it's not a pre-deployment by setting the flag to false, but you do need to set the delete deployment to true to delete the ADF deployment entry from the deployment history in ORM, as it says here in the notes. So that's everything you need to know about how to use the PowerShell script in your pipelines. The next thing we want to do is to take this PowerShell script, which is version 2, into our DevOps repository so that we can use it in our pipeline. I've already downloaded this file into my laptop, but please feel free to download the file from here yourself, or in case you want to use the file I'm using, I'll make it available as part of the course resources and you can use that as well. So let me show you the file I've got here. So that's in my downloads folder and that's the script here. Let me open that up in Visual Studio Code. As you can see here, this is quite a long PowerShell script. I would encourage you to go through that if you're familiar with PowerShell. Otherwise, don't worry about it. But there is some description and the details about the parameters here if you want to read it through as well. Let's now navigate to Azure DevOps and add this file to our DevOps repo. So here I am in Azure DevOps. And we need to now establish where to add the file. So I've seen a lot of people adding the script into ADF publish branch, but I wouldn't recommend you doing that because ADF publish is managed by ADF. So I would encourage you to add it to the main branch and follow the proper development process. What that means is create a feature branch, put the file in, and then merge that to your main branch. So you can go through reviews and you can go through the proper development processes. So let's go to branches. As you can see, I am going to use this UI to create the branch and also add the script, but you can use something like Visual Studio Code or Visual Studio to do what you want to do. But let me do this first. So I'm going to click on new branch and I'm going to create a new branch here. So let's go over to the feature branch and add a folder under which we want to put the script. So let's create a new folder here to keep the script for releases. So this is for our release pipeline. So I'm going to create a new folder and I'm going to call this as a release. So we're going to keep everything that goes into the release pipeline into this folder. You can't create a folder without a file. So I'm going to create a dummy file called readme.md. And let's do a commit. So that's going to be committed to the feature branch. Now we need to add the file, which is the post deployment version 2.ps1. So I'm going to just simply click on upload and bring in the file from my downloads folder. And let's click commit. And now we've got that file within this folder in the feature branch. So we want to create a pull request so that we can merge it. And I'm going to add me as the reviewer and let's click create and follow the normal process we follow, which is to approve and complete the pull request. So now when I navigate to my main branch, I'm going to have the release folder with the PowerShell script. So that's all I wanted. So the next thing we want to do is to add this file as an artifact to the release pipeline. So I'm going to go to the release pipeline. So in order to edit the release pipeline, so you just click on the edit button here, and now you can add the artifact. The artifact here we got is with the default branch of ADF publish. So we want to add another one to get the information from the main branch. So I'm going to simply click add, and I'm going to select Azure repos, and let's click select the project and get the repository, and also bring in the default branch, which is the main branch. So I'm going to slightly rename the alias so we can differentiate between the ADF publish branch and the main branch, because the first one is called CICD demo ADF, and we can't give the same name here. So I'm going to just call it as underscore or hyphen main would be better. And let me click add. So now that's been added. We don't want to have any continuous deployment triggers here because we only want to run the release pipeline when there is a change to the ADF publish branch rather than the main branch. So we're going to leave that as it is. And now this artifact is available for us to use within the release pipeline. The next thing we want to do is to add the PowerShell task. So I'm going to click on the hyperlink here and I'm going to click on add job here. And this time we're going to search for Azure PowerShell and let's click add here. So that's now been added. So let's click on that and let's rename the task name. So that's going to be called pre-deployment. And we need to pick the Azure subscription. As we know, we already have a connection, so let's pick that one here. And we can have the script inline or as a file path. In our case, we've got the file in our artifact anyway, so we can pick the script from the artifact. So let's click on the three dots here to browse. And we know the script is under the main artifact, so I'm going to go there. And that's under the release folder. And let's click select on that. And let's click OK. So that's now done. So the next thing is to provide the arguments. So we need to provide the arguments. So let's go to the documentation and get the arguments. So that's in here. And we want the pre-deployment argument, so I'm going to just simply copy that and come over to DevOps and paste it here, but we need to make changes. So we need the location of the ARM template, which we know we specified that as part of the ARM template deployment. So let's go over there and copy the information. So if I go down, I'm going to find the artifact template information or the location. So let me copy that and let me come over, and that's the one we want to specify within this double quotes here. So let me specify that, and we need to specify the resource group. So I'm going to just key in the resource group. That's going to be the test CICD demo RG, I think. And let me also specify the data factory name, which is test CICD demo ADF. And we can leave the pre-deployment as true and the deployment as false. So the last thing we want to specify is the PowerShell version. We can go for the latest install version on this agent. That's everything, so that's all done. But as you can see, now it's going to run after the template deployment. We don't want that. We want to run it before the template deployment, so we'll just drag that over. So now that we've got the pre-deployment task, let's create the post-deployment. So instead of doing everything again by hand, we can just clone this task. So I'm going to simply right-click on that and clone tasks. So that's been cloned. But again, we want to push the ARM template deployment in the middle and then do the post-deployment. So I'm going to simply rename that post-deployment. And the only change we need to make is the parameters. So this time we're going to say the pre-deployment as false and the delete deployment as true. So with that, we've completed the development of the pipeline. So we've got the three tasks we wanted, which is the pre and the post deployment and the ARM template deployment. So let's click on save to save the changes. We now need to test the changes that we made here. So we've got two options. One is we can create a release pipeline here manually and then see the changes, or we can trigger a change from our dev data factory and see the continuous deployment and the changes in action. So that's what I'm going to do, so that in one go we can test both the continuous deployment as well as the changes we made. So let's go over to the dev data factory. Let's make a simple change to this pipeline. So in order to do that, we're going to create a new branch and we'll make the changes in that feature branch. And I'm simply going to update the name of this activity. So I'm going to go from wait 1 to wait. And let me click save all, and that should save the changes to our feature branch, and we want to create a pull request and merge the changes. I'm going to quickly do that. We've done this quite a few times, so let's do that. And let's click approve and complete the change. Everything's merged to the main branch. So the changes are now merged to the main branch. Let's go over to the dev data factory again, switch to the main branch and publish the changes to ADF. So that'll create our ADF publish branch as well as update the dev repository. So the publishing is now complete, so we would expect to see the release pipeline running at the moment. So as you can see, we've got release 6 going. So you're not seeing release 5, that's because I've had to abandon one of the releases there. So let's have a quick look at this, and I'm going to go into release 6 and let's look at the logs. So the deployment is now completed. Just let me explain before we go ahead and look for the changes. As I said before, we went from release 4 to 6. That's because I created a release, which is release 5, with the deployment script or the pre and the post deployment script from GitHub and ran that through and it failed. That's because the script has got an issue at the moment. So what I did is I took a previous version of the script and that's what I'm using. I'm going to make that script available for you in the course resources. So please use that if you find any issues with the script supplied by Microsoft. So let's go over to our test data factory and ensure that the changes have worked. So I'm in the test data factory now, and let's do a refresh here. As you can see here, we've gone from pipeline 1 and 2 to pipeline 1. So the deletion has been applied as we expected to see. The other thing we wanted to see is that the trigger has been updated. So let's have a quick look at that. As you can see here, we've got the trigger which is in started stage. If you remember previously, we used to have the triggers when they're deployed, they'll be in stopped, and then you had to manually start that. And let's click on the trigger and see whether it's got an end date. And as you can see here, we've gone from an open-ended to an end date. That's the change we made. So both changes have been applied, and also we now have a release pipeline which has fixed the issues we talked about. So it's now fixed the issue around deleted objects. So it is applying deletions to the objects, and also it's able to deploy trigger changes even though the triggers are in started or active state. So that's the end of this lesson. I'll see you in the next one.
Thank you, sir.
In the next lesson, we're going to extend this release pipeline to add another stage called production to deploy the ARM template to the production data factory. But before that, I want to change the hard-coded values within this pipeline and use variables instead, so that it'll be easier for us to copy the stage and just make a few changes to work for production. So let me show you what I'm talking about. So let's go into the tasks, and if you go to the template development, you're going to see some of those hard-coded values. As you can see here, we've hard-coded the resource group, we've got hard-coded the location, and also we've hard-coded the data factory name. So if we can use variables instead of these hard-coded values, we'll be able to copy these tasks as they are and create another stage and just change the variable values within that stage. So in order to do that, we want to create some variables. So let's just go to variables here. And as you can see here, you can create pipeline variables as well as variable groups. Variable groups gives you more flexibility and allows you to do some clever things, but we're not going to go into that at the moment. But I would highly encourage you to look at variable groups as well. Instead, we're going to use pipeline variables and keep it simple. I'm going to add 3 variables, as I said, 1 for the data factory name, 1 for the location, 1 for the resource group. Let me do that. I've added the 3 variables here, but I want to change the scope. I want them to be within the test scope rather than the entire release. So let me just change them to test, because the values are only applicable for our test stage. When we come to do production, we'll have a production scope and the values will be different. So you will have the data factory as production or prod, CI/CD, demo, ADF. Similarly, you can have your production data factory in a different location as well. So that's why we got these 3 variables. So that's done now. So let's switch over to our pipeline and let's go to the tasks and let's start making the changes. So we want to start with the pre-deployment script. The first place we want to make the change is the resource group name here in the script arguments. So to use a variable, you need to use dollar and then use the normal brackets and put the variable name. So I call this one as resource group. So I'm just typing in resource group, and the data factory name goes here. Again, I'm going to use the dollar and the standard bracket, and I'm going to use data factory. Make sure you're using the right casing as well. And that's everything here. And we need to make similar changes to the ADF template deployment here. I'm going to do that as well. And that's everything here. Let's do the post deployment as well. And that's all the changes we wanted to make. Let's save the changes now. And let's do a quick test. Instead of doing a continuous deployment by making a change to our data factory, I'm going to create a manual release. So let me just click on create release and then click create. And that should create another release. So as you can see, we've got release 7 that's been created. And let's go into the release 7 and make sure that it works. The deployment has now completed and there are no errors. So all we've done is we've used the variables instead of the hard-coded values. And as I said, that'll become really handy when we come to clone this stage to create our production stage. I'll show you that in the next lesson. Now that we've completed building the release pipeline to deploy to test, let's look at deploying to prod. As we discussed before, we just need to create another stage called prod with the same tasks, but pointing at the production data factory. The only difference in the pipeline execution is that we want this stage to wait for an approval process. Let's switch over to DevOps to make these changes. Here we are in the DevOps pipeline. We can do a couple of things to create the production stage. The first one is you can simply add a new stage and call that as production and then create your tasks. But we don't want to be doing that. We want to clone this stage. That's because we have all the tasks already defined here. We can simply copy that and then make the corresponding changes we want to do. So in order to do that, click on the add and clone stage. So that's going to create a new stage and that's called copy of test. We're going to just rename that. I'm going to call that as prod. And let's go into the tasks now and take a look at that. As we can see, we're using variables. So we don't have to make any changes here, but we do have to add new variables because we don't want to be using the variables from our test stage. So let's go to variables. And as you can see, we've got 3 new variables created that happened as part of the cloning stage. So when you cloned from test to the production stage, it cloned all the variables as well. But as you can see, even within the production scope, the variables have got the values with the test data factory name and the test resource group name. So we simply have to change them to prod. And that's everything we need to do to the pipeline. There's one more thing we need to do in order for our pipeline to work. Let me show you what that is. Let me go over to the tasks, and we are in the production stage. And if you look here, the connection that we created, which is the service connection with the service principal, that only has access to the resource group test CI/CD demo OG. As you can imagine, we want that connection to have access to the production resource group as well, so that it can deploy the ARM template. So we need to give access to that service principal. I showed you previously how to identify the service principal created from this one. That's normally got the organization name as the prefix, and then you've got the project name, and then you've got the subscription ID. But you can click on the manage link here to get the actual name of the service principal. So you come over here, and then you can click on manage service principal, and that'll show you the full name of the service principal. So this is the actual name of the service principal. Let's copy that, and we need to provide access to this service principal for our resource group with a contributor role. So let's go back to our home and let's find the resource group, which is the prod CI/CD demo OG, and let's go to IAM and let's click add and click on role assignment, and we want to add the role as contributor, and let's click next, and we want to assign access to a service principal. So let's leave that checked here, and then click on select members, and now search for that service principal. I'm going to just simply paste that, and that'll bring up the service principal as you can see here, and I'm going to just select that and click on select, and that gets added here, and I'm going to click next and click on review plus assign. So now that role has been added. Let me show you that one more time. So if you click on access control and then look at role assignments, you're going to see this service principal having contributor access to our resource group. Now, our service connection that we've got within DevOps can deploy to this resource group. So that's all we wanted. So let's switch back to DevOps and let's go back to our pipeline, and we've got a continuous deployment pipeline ready. One more thing we want to do, which I forgot about, is the precondition for our production deployment. We wouldn't want to have a continuous deployment to production. We wanted to have an approval. So in order to do that, click on the trigger icon here and then enable the pre-deployment approvals. So you can add your approvers here. I'm going to simply add my details here. So what happens is once the test deployment is completed, it's going to wait for me to come and approve, and you can specify a timeout. So after that timeout period, this deployment becomes invalid or it will be automatically rejected. So I'm going to just leave that as 30 days. That's everything we wanted to do. So let's click close and click on save, and the pipeline gets saved now. So now that we've completed the release pipeline, we just need to test it. So in order to do that, I'm going to create a new pipeline within my dev data factory. I'm going to create a new feature branch and merge that and publish the changes so that the continuous deployment happens. Let me quickly go ahead and do them. As you can see, I've simply created another pipeline called PL Pipeline 3, and that's got a wait activity as well. So I'm going to quickly save that change, and I'm going to create a pull request and merge these changes. Let's now go ahead and publish the changes so that the continuous deployment starts to happen. So let me go over to the release pipelines and see the releases. So as you can see, we've got release 8 now created, but we can see 2 stages as well, test and prod. We only used to have test, but now we've got prod as well. So let me click on the release 8, and then we can see the progress. So it succeeded, and the pipeline has successfully completed the deployment to test stage. As you can see here, the production stage is not running, it's pending approval. Let's first check the test data factory to ensure that the deployment has happened. So we expect to see another pipeline. Let's make click refresh, and we got the third pipeline as well. But the production data factory, as you can imagine, is totally empty because we haven't done any deployments yet, because it's waiting for an approval. So whenever it's waiting for an approval, it'll send out an email to the approver. So that might be a senior manager in your team, so they'll get an email. In my case, I just gave my email address here. So let me go and check whether I've got an email. So as you can see here, I've got an email to say that the deployment to stage prod is waiting for an approval. I can click here for the approval, or I can just go simply into DevOps and click approve. So if you hover over the stage here, the approval button becomes enabled. So you just click on that. And you can add a comment saying the test succeeded, so I'll approve it, or something similar. Just put something which is meaningful, and then click on approve. And now that's being queued, and that production stage will start to execute as well. As you can see, the production stage has successfully completed as well. If you go over to releases, now you'll see both of them as green ticks. That's what indicates that the deployment to both of these stages have completed successfully. Let's go over to our production data factory and ensure that the deployment has happened. So let me click refresh here, and I should see the 2 pipelines. I am seeing the 2 pipelines, and also we've had a trigger that should appear here as well. So both stages of our pipeline has successfully completed, and we now have a release pipeline which will take our own template from the area of publish branch and deploys to both test as well as production. In your project, if you happen to have more than one test environment, you can just add more stages and you just go along. One thing I want to reiterate is that we've used the pipeline variables here, but variable groups gives you more capability, so have a look at those as well. And that's the end of this lesson. I'll see. Welcome back. Now that we've completed implementing continuous integration and continuous delivery using option 1 of our solution, let's quickly look at the part of the solution that we couldn't automate in option 1 and rectify that in option 2. As you know, the manual step in the solution was in the build stage. Once the pull request was completed, we always had to go back to the data factory and click on the publish button to generate the ORM template. Publish button offered 2 things related to build. It first validated the data factory resources, and then it generated the ORM template and stored that in the area of publish branch. Wouldn't it be nice if we can automate this and validate the data factory resources as well as create the ORM templates as soon as the pull request has been completed? Azure now offers an NPM package called Azure Data Factory Utilities, which offers these capabilities. We can create a DevOps build pipeline to invoke this NPM package. On successful build, the pipeline will create the build artifact with the ORM template. We can then simply change the release pipeline to consume the ORM template from the build artifact. The release pipeline can then also deploy the ORM template to the dev data factory alongside test and production. That's our option 2, which is a fully automated continuous integration and continuous delivery solution. Microsoft provides a reasonable amount of documentation around the NPM package and how to use that in the build pipeline. Let's switch over to the documentation and have a look at that. Here's the documentation from Microsoft about the automated publishing for continuous integration and delivery. I'm going to leave a link for the URL in the course resources, but I would highly encourage you to read this documentation. But I'm going to quickly walk you through this one. So let's just scroll down to the diagrams. As you can see, this is what they call as the current CI/CD flow. We call it as option 1. It's very similar to what I explained, but I'll quickly walk you through this one. As we did, actually, we need to create feature branches in order to make any changes to the dev data factory, and then we create pull request, and that gets merged into the master branch or the main branch. But then comes the manual step. In that manual step, once it's merged to the master or the main branch, we'll hit the publish button, and that generates the ORM template as well as that deploys to the data factory in development. And then we created the release pipeline to pull the ORM template and deploy to QA or test and production. So that's exactly what we did. And let's now look at the new solution being proposed, and that includes a build pipeline to do continuous integration. So let me walk you through this one. As we did with the other one, we'll create a feature branch to make the changes to our dev data factory. We'll then create a pull request, and the pull request gets completed, and the feature branch is merged into the master or the main branch. And now we want to automatically trigger a build pipeline. So we can create a DevOps build pipelines, which is waiting for changes to the master or the main branch. So based on that, it triggers the build pipeline, and in the build pipeline, we will call the area of utility NPM package, and that creates a build. That basically validates the data factory resources as well as that generates the ORM template. And what we can do now is we can use the release pipeline to pull the artifacts from the result of build pipeline, and then we can deploy that to the dev, QA, and the prod data factories. As you can see, in option 1, we had the publish button here instead of the build pipeline, which created the ORM template as well as deployed to the dev data factory. But here, we create the ORM template as part of the build, and then the release pipeline deploys to dev, QA, and the production pipeline. I've seen some people having the deployment to dev as part of the build pipeline rather than the release pipeline, and keeping the release pipeline to deploy to just test and prod. I've seen both kind of examples in the industry, but we'll stick to the solution proposed here in the documentation. And now here, the documentation talks about what's changed between option 1 and 2, and they call it current and the new solution. And let's go down here, and now you've got some documentation about the package and how to invoke the package. But if you go down, it even talks about how to create a pipeline. So for the pipeline, we need the package. So as we said, we got the npm package to be deployed. So we need to have that specified within a file called package.json. And the contents of the package.json file is given here. There is a syntax error at the moment here. As you can see, there is an additional comma. But I have created my file without this syntax error, and I'll make that available as part of the course resources again. So for the build pipeline, again, we can use the classic editor or we can use the YAML pipeline. But in this case, Microsoft's given the example with the YAML details here. So we're going to create a build pipeline with the YAML configuration details given here. If you're not familiar with YAML, don't worry. It's very similar to JSON. It's a data serialization language which is mainly used to create configuration files like this. So what I have done is I've taken this YAML and made a couple of changes. It's not significant changes. Mainly what I have done is I have taken these hard-coded values from here and created variables to use so that it'll be easier for you guys to adapt. I'm going to talk you through that in the next lesson, so don't worry. It looks big, but it is very simple. And that's the end of this lesson. I hope you now have an initial understanding about the option 2 or the fully automated solution. I'll see you next. Welcome back. Before we start creating the build pipeline, I just wanted to give you a quick overview about the package.json file and the YAML configuration file. Let's start with the package.json file. So the package.json file is basically a copy from the documentation. It's simply got the information or the instructions to install the Azure Data Factory Utilities npm package. And we're going to use the version 1.0. And let's now go through the YAML file configuration file. So on the top, I've added some comments. The way you comment within the YAML file is using the hash. And this is where the instructions start. So the first one we've got is trigger. That informs us when to trigger the build pipeline. So we want our build pipeline to be triggered as soon as we merged the changes to the collaboration branch or the main branch in this case. So that's what we've specified here. And the next thing we are specifying is the VM image. We're going to use the bundle latest. And now we're defining the variables. This is something you probably won't find in the documentation, but I've just added some variables so it'll be easier to replace them further down. So you don't have to make any changes within this configuration file other than just changing these variables because I've used the variables later down within the configuration file. So the first one is the subscription ID, which you can go to any of the resources within your Azure portal and you can get that information. And the next thing is the resource group for our data factory, which is dev CICD demo org in my case. And the next information is data factory name. That's again dev CICD demo ADF. And then we've got the package folder. So that is basically the folder within Azure Git repo where we are going to keep the package.json file. I'm planning to keep that within the build folder. So that's why I've given that as build. And the next thing is the ADF root folder. If you remember, when we configured our data factory to use Git as the repository, it asked us to specify a root folder if we wanted to, and we left that as blank. So that's why I'm leaving that as blank. But if you had given a folder name at that time, please use that here. So now the important things. Before we start that, I may as well tell you that similar to the release pipeline that we created, we can have stages. If you remember, we had test and production stages. We can do that within the YAML pipeline as well, but we're just keeping that as simple here and just specifying the tasks. There are basically 5 tasks within this build pipeline. The first one installs Node.js, and the second one installs the npm package, which is as specified here, which is the Azure Data Factory Utilities package. So that installs the npm package. So now we've got the npm package, we can use that. So the next task basically validates all the data factory resources. So it's basically running that npm package and validating our dev data factory. We do specify the data factory details here. As you can see, I've used the ADF root folder part in the path here, and also if you scroll to the right, you're going to see the data factory name as well. You can choose to hardcode it, but I've used the variables here. So the next one we've got here is to generate the ON templates. Once we validated it and everything is okay, we're going to generate the ON template and put it in a destination folder. And that's what this one does. Basically, again, it's using the same npm package, which is the Azure Data Factory Utilities package, to generate the ON template. Once we've generated the ON templates, we want to publish that to the artifact so that the release pipeline can consume that artifact. So that's what this task does, basically. That's everything about the 5 tasks we've got within the YAML configuration. I just want to reiterate that I've used the variables here within the pipeline. That's one way of using variables, but you can use variables by defining them within DevOps, and also you've got the option to define them within Key Vault and then use that within DevOps as well. So if you have any sensitive information, that's what you would do, but I'm just keeping it simple. I would encourage you to go and read about DevOps variables and how to use them and things like that, so that if you have any sensitive information, you can put them into Key Vault or store it somewhere secure. Now that we understand the significance of these 2 files, which is the package file and the YAML configuration file, let's add them to our Git repository. So let me switch over to my Git repository here, and in order to add any files, we need to create a feature branch. So I'm going to quickly create a feature branch. And let me quickly navigate to the branch, and I'm going to create a new folder. As we discussed before, we want to call our folder as build, and I'm going to give a readme.md file as well. So let me click create, and I'm going to add some contents. And let me commit the changes here. And now we need to add the other 2 files, which are the package.json file and the YAML configuration file. So let me click on the 3 dots here and click on upload files and browse to the files here. And I'm going to add both files here, which is the package and the YAML configuration file. And let me click commit. And we've done all the changes we wanted to make. So we got the build folder with the 2 files we want to see. So let me quickly create a pull request and add the files. The pull request has now been merged, and we should see all the files here in the main branch. So we got the build folder with the 2 files. So that's the end of this lesson. In the next lesson, we'll create the build pipe. In this lesson, we're going to create the build pipeline. So in order to create the build pipeline, you come over to the left-hand menu and click on pipelines. Please note that for creating release pipelines, we click on releases, but now for the build pipeline, you click on pipelines and click on create pipeline. Now we specify where our code is. We know that our YAML configuration file is in Azure repos Git. So we need to select that one. But before that, let me talk about this. As you can see here, if you wanted to use the classic editor, you can click on the hyperlink here and use the classic editor like we did before for the release pipelines. But in this case, we've got the YAML configuration files. So let's go with the YAML configuration files. So I'm going to select the Azure repos Git. And let me select my Azure repo. And here you've got some templates, or you can go for a start pipeline from scratch, or you can use your own YAML file. That's what we're going to do because we already created our YAML file. So you click on existing Azure pipelines YAML file, and now it shows you the branch. Our code is within the main branch, and we want to pick the YAML file. There is only one YAML file, so it's just listed that YAML file here, which is my configuration file, ADF CI option 2 build pipeline YAML. And let me click continue. And as you can see, this is basically the file we went through before, and that's the file we uploaded. So it's got all the information as we expect to see. we need to save this pipeline, but before that, let me copy the build pipeline name that I wanted to use. I'm going to just simply copy that so that I can use it later. And let's click on the drop down and click save. So the pipeline's now been saved, but it's been given some random name, which is dev CICD demo ADF, which is my repo name. So I want to change that one. So in order to do that, you can click on the three dots on the right, which is more actions, and then click on rename, and you just have to change the name. So I've just given that as ADF CI option 2 build pipeline, because that's what I wanted to call it as. And let me click save. So the pipeline's now been created. So let me go back to the pipelines and show you one more time. So let me click on the pipeline. As you can see here, this is the recent pipeline. You can click on all here as well. It'll show you, and you can click on the pipeline to get to that. And if you click edit here, you'll see all the code as well. So there are a couple of things you can do to test it. One, you can click on the button here, run, so that it runs and you can see whether that's worked. Or you can make a change to your dev data factory and then that'll trigger the pipeline to run. So let's do a quick run here to see whether that works, and then we can trigger via the dev data factory. So I'm going to simply click run here and click run again, and that should start to run now. Let me click on the job. As you can see, the job's now being queued and we should see all the information appearing here now. So as you can see here, it's checked out the code, it's installed the Node.js and installed the NPM package, and the validation of the data factory resources is successful as well, and it's done the generation of the ARM template, and it's just published the ARM template now. So that's available for our release pipeline to go and consume. So let's go back to the job, and we should be able to see the artifact. As you can see here, there is one artifact published, which we can consume from a release pipeline. So let me click on that, and as you can see, you're seeing everything we previously saw within our ADF publish branch. So that's exactly what we wanted. We got the ARM template and the ARM template parameters, and they are the ones we'll use within our release pipeline. As you can see, creating a build pipeline using the YAML configuration is quite simple. So there's one more test to do, which is to trigger this pipeline by making a change to our dev data factory. So let's do that. So I'm in my dev data factory. I'm going to follow the development process, which is to create a feature branch and make the changes. And I'm going to make a simple change. I'm going to change the name of the activity from wait1 to wait for 1 second. And let's save all the changes, and let's create a pull request. The merge is now complete. As you know, we don't need to go and hit the publish button anymore. It should do an automatic build. So let's go over to our pipelines and see whether the build has started. And as you can see here, the build is in progress. So I'm going to click on this, and that's the previous build we did, which was successful. And we're doing the next build here, which is updating the pipeline 3, and the job is currently running and it's completed as well just now. It was seamless, and we've got the artifact being published as well. So with that, we've now automated the build of our Azure Data Factory and published the ARM template. That's the end of this lesson. I'll see you in the next one. In this lesson, we're going to create a release pipeline that consumes the ARM template published by the build pipeline. So let's start doing that. Instead of creating a pipeline from scratch, let's clone this pipeline and make the changes. So in order to clone the pipeline, you come over to the three dots here and click on clone. And that's created a new pipeline with the name, with the suffix as copy. I'm going to simply change that and call it as ADF CD option 2 release pipeline. And the first thing we want to do is to add the artifact. As you know, the ARM template for this release pipeline now is coming from the build pipeline rather than the ADF publish branch. So this artifact here is pointing to the ADF publish branch, which we need to delete. And instead, we need to replace that with the build pipeline artifact. So I'm going to simply click delete and click confirm. And we're going to add the new artifact. As we said, that's coming from the build pipeline. So let's select the build pipeline. And we want the latest version of the artifact. I'm going to leave the source alias as it is. And let's click add. So the artifact is now added, but we need to use that ARM template in our tasks. So let's go over to the test tasks. We use that in all 3 of the tasks here, but we'll start with the ARM template deployment. And if we go down, as you can see here, we use that from our repository, but we don't want to be doing that. We want to be using the ARM template that's coming from the build pipeline. So let's click on the 3 dots here. And because we linked the artifact to this pipeline, it's now available here. So let's select the ARM template. So that's this one. Let's click OK. And let's do the same for our parameters as well. And let's click OK. I'm going to copy this value here, which is for the ARM template. I'm going to use that in the pre and the post deployment. I'll show you where we need to make the change. So click on the pre-deployment. As you know, when we invoke the PowerShell, we gave script arguments as well here. And one of the arguments is the ARM template location. So that's what is here. I'm going to simply replace with what I copied. And let's do the same for the post deployment. So that's done as well. So let's switch back to our pipeline and make the same change to our production stage as well. So I'm going to start with the ARM template and then do the pre and the post scripts as well. So with that, we've completed all the changes to the test and the production stages. So let's switch back to our pipeline and let's save these changes first. There is one more change we need to make, which is to deploy to our dev data factory. As you know, in the past, the publish button also deployed to the dev data factory, but that is not. Stage and create another stage called dev. So I've renamed the stage to dev, and also we need to change the variables for it.
నాకు రాదు.
So that's what is here. I'm going to simply click delete and click confirm. And we're going to add the new artifact. As we said, that's coming from the build pipeline. So let's select the build pipeline. And we want the latest version of the artifact. I'm going to leave the source alias as it is. And let's click add. So the artifact is now added, but we need to use that ARM template in our tasks. So let's go over to the test tasks. We use that in all 3 of the tasks here, but we'll start with the ARM template deployment. And if we go down, as you can see here, we use that from our repository, but we don't want to be doing that. We want to be using the ARM template that's coming from the build pipeline. So let's click on the 3 dots here. And because we linked the artifact to this pipeline, it's now available here. So let's select the ARM template. So that's this one. Let's click OK. And let's do the same for our parameters as well. And let's click OK. I'm going to copy this value here, which is for the ARM template. I'm going to use that in the pre and the post deployment. I'll show you where we need to make the change. So click on the pre-deployment. As you know, when we invoke the PowerShell, we gave script arguments as well here. And one of the arguments is the ARM template location. So that's what is here. I'm going to simply replace with what I copied. And let's do the same for the post deployment. So that's done as well. So let's switch back to our pipeline and make the same change to our production stage as well. So I'm going to start with the ARM template and then do the pre and the post scripts as well. So with that, we've completed all the changes to the test and the production stages. So let's switch back to our pipeline and let's save these changes first. There is one more change we need to make, which is to deploy to our dev data factory. As you know, in the past, the publish button also deployed to the dev data factory, but that is no longer the case with the build pipeline. So we'll have to release to dev data factory and then to test and then to production. So let's do that. In order to do that, I'm going to simply clone the test stage and create another stage called dev. So I've renamed the stage to dev and
ఈనాడే తీసుకోవాలా ఎవరిది సరే సరే
So we need to change the variables for this. So I'm going to simply go to variables, and under dev, it's still pointing to the test data factory. So I'm going to simply change that to dev and the resource group to the dev resource group as well. So those changes are done. And there is one thing we need to change here is to correct the order of execution. At the moment, test executes first. We wouldn't want that. We want dev to execute first and then test followed by production. So that's what I'm going to do. That is slightly funny at times. So I'm going to change test to manual to start with, and then change dev to be after release. So that's happened now. And I'm going to change test to follow the stage dev. I've noticed a couple of times in the past, if I didn't do it in this order and if I changed dev to follow release while test is attached to release as well, I had some errors. So this should work. There are no errors being shown anywhere. So let's click on save. The last thing we want to do is to provide access for our service connection to deploy to our dev resource groups. Because as you know, we gave access to our test resource group and the production resource group, but we don't have access to the dev resource group. So let's quickly copy the service principal name so that we can keep the right access. And that's the name of the service principal to which we need to give access. So I'm going to quickly go over to the Azure portal and let's pick the dev resource group from here. So that's my dev resource group. I'm going to go to access control and add a role. And the role is going to be contributor. And let's click next. And we want to pick the service principal from here. So I'm going to simply paste the name of the service principal and select that and click on review plus assign. So now our service connection from DevOps has got access to this resource group, so we can deploy to this resource group. So let's go back to our release pipeline. And now we're ready to test this. Instead of testing it by triggering a change from the dev data factory, looking over the build pipeline and then the release pipeline, let's just simply test this in isolation to make sure it works before we do an end-to-end test. So I'm going to create a manual release. So I'm going to click on create new release and click create here. So let's watch that go through. Dev stage has now succeeded, so let's go over to the dev data factory and make sure that the changes have been applied. So I'm going to go over to the live mode, so switch to live mode, and then if I go to that pipeline, which is pipeline 3, and that's got the new name that I have given. So the changes have worked, so let's wait for the test and the production deployments to go through now. So the test stage has now succeeded as well. So let's go over to the test data factory to ensure that the changes have come through. So I'm in the test data factory now. So let's click on author and I'm going to quickly simply refresh this and we should see the pipelines. As you can see, the pipeline 3 now has got wait for 1 second as the name. So now let's go back to the release pipeline. As we know, for the production, we need a manual approval. So I'm going to simply click on approve and approve my own changes. As I said before, in your organization, you will probably have someone else approving your changes normally. So let me click approve and that should trigger the deployment to production now. And finally, the production deployment has succeeded as well. So let's go over to the production data factory and let's check the pipeline. So which is the pipeline 3. We still have the old name here. That's because I haven't refreshed it. So let me click refresh and we should see the new name for the activity here. So which is wait for 1 second. Just to summarize, we've now got a release pipeline which takes the artifact, which is our own template, from the build pipeline and deploys to dev, test, and prod. And the prod has got a manual approval process. And that's the end of this lesson. I'll see you in the next one. Welcome back. Now that we put together a build pipeline and a release pipeline, we just need to enable continuous deployment so that we have a fully automated continuous integration and continuous delivery. In this lesson, we'll enable continuous deployment and test the end-to-end process by creating a new data factory pipeline in the dev data factory and see that being built and deployed to the test and production environments without any manual intervention. Let's get started. Here we are in DevOps. As we know, our build pipeline has got a trigger, so let me click on edit, and that's triggered as soon as we've got a change to our main branch. But we also need to trigger the release pipeline as soon as the build has completed. So in order to do that, you come over to the release pipeline and click on edit, and then you want to enable continuous deployment. So that'll be on the artifact from the build pipeline. So I'm going to click on the trigger here and then click on enabled. So now the continuous deployment has been enabled. So let me close that and save this change. With that, we made all the changes that we need for our DevOps pipelines, and let's go over to our dev data factory and start the test process. So I'm in the dev data factory. I'm going to create a new pipeline, as I said. So in order to do that, we know that we need to create a new feature branch. And let's click create, and now we want to add a new pipeline. So I'm going to simply clone this pipeline and rename that. So I'm going to call this as PL pipeline 4. And that's everything we wanted to do. So we got a new pipeline in our dev data factory. So I'm going to simply click save all. So that's being saved to our feature branch. And now, as we know, we need to create a pull request in order to merge to our master of the main branch. So I'm going to create a pull request and add me as the reviewer. And I'm going to approve the changes. Before that, let's make sure that's the only change. As you can see, we got a new pipeline called PL pipeline 4. And let me click approve. And also let me click on complete and complete the merge. So let me go over to the overview tab, and it's now merging the pull request. And once the merge has happened, we should have the build pipeline triggering. So the merge is now completed. So let me go over to the build pipeline. So I'm going to go to pipelines here. And as you can see, it's running at the moment. So let me go into that and let me have a look at it. And the jobs are now running. So the build has now completed. So let's go back and make sure we got an artifact. We got the artifact, and that's the ARM template. So now if we go over to the release pipeline, we should have that triggered as well. As you can see, we've got a new release here, release 2, and that's got 3 stages. Nothing has started yet, but let's go in. And as you can see now, the dev stage is in progress. I'm going to let the deployments go through. The dev deployment's now succeeded, so let's go over to the dev data factory and make sure that we've got the pipeline 4 in our live mode as well. So I'm going to switch to live mode now, and we should see that 4th pipeline or PL pipeline 4, and we can see that here. So let's go back to our release pipeline and wait for the test stage to complete. As you can see, the test stage has now succeeded. I'm going to approve the production stage as well. And let's go over to the test data factory to ensure that the changes have been applied. I'm going to simply refresh and be seeing the 4th pipeline as well. So let me go back to the release pipeline and wait for the production stage to complete. As you can see, the production stage has now completed as well. So let's ensure that the pipeline appears there, and it's there as well. So as you can see, we've implemented a build and a release pipeline to seamlessly deploy our code from dev to test to production without any manual intervention. So it is quite simple when you think about option 2 alone, but just because we've had option 1, that makes things slightly more complicated. So if you are implementing a new project, please don't worry about option 1. Go directly for option 2 is what I would recommend. But if you have an existing project which is already using the option 1 as your DevOps pipelines, I hope you got a good understanding about how to implement that and how to maintain that as well. And that's the end of this lesson. I'll see you in the next.
ఎండాకాలం మనము
Now that we managed to create
ఎంత అంత మేలు అనవసరంగా
an end-to-end CI/CD pipeline, let's look into some of the scenarios that you're likely to come across in production level projects. So far, we've just been dealing with data factory pipelines that are self-contained, i.e. they don't access any other resources. In a production scenario, that won't be the case. ADF pipelines will be accessing data from other storage solutions such as Azure Data Lake and SQL Database, and also they'll be executing workloads on other compute engines such as Databricks, HD Insight, etc. As a minimum, most projects will have a data lake from which the ADF pipelines read and write data to. So let's take a look at that. In this example, a development data factory is accessing data from an Azure Data Lake storage which is specific for development environment. With the release pipelines we've developed so far, when this code has been deployed to test and production environments, those data factories will also be pointing at the development data lake storage, which is not something we want to happen. Instead, we want them to be pointing at the test and production data lake storages respectively. In order to do this, we can override the ARM template parameters in the release pipelines. This is very similar to what we did for the data factory names earlier. But the problem doesn't stop here. We need to think about how the data factory gets the credentials and the access required in order to interact with the data lake storage. Currently, ADF offers 4 different authentication options. Firstly, you can use the access keys of the storage account to access that. You can also access the storage account via a service principal, a system assigned managed identity, or a user assigned managed identity. Out of this, the continuous deployment approach for service principal and the managed identities are exactly the same, but the approach required for using the access keys is different. We'll look at both approaches in this section of the course. First, we'll implement a solution using the system assigned managed identity, and then we'll tackle the usage of access keys. Having said that, I think I said this before, whenever possible, please use managed identities for access as they are more secure, but I will take you through both approaches in the forthcoming lessons. Let's get started. In this lesson, we're going to create the data lake storage accounts required in order to implement our solution. As you can see, we need 3 data lake storage accounts to be created, 1 per environment. Before creating them, let's take a look at the naming standards that we're going to use. We'll be keeping the names of the data lakes consistent with the data factory names and the resource group names. Also, we'll create them in the same resource group that we use for the data factories. Please feel free to use a different resource group if your project requires you to keep them separate for any security reasons. Let's switch over to the Azure portal and start creating the data lakes and upload some data. Here we are in the Azure portal. Let's start with creating the data lake storage required for our development environment. So I'm going to click on create a resource and search for storage account. And let's click create here and pick the subscription, which is my basic Go subscription. And as we discussed before, we are going to use the same resource groups, which is my dev CI/CD demo org for my dev work. And I'm going to provide the storage account name. As we discussed, we're going to keep it consistent and go for dev CI/CD demo DL for data lake. And I'm going to pick my closest region, which is UK South. And let's keep the performance as standard. And we just need the lowest amount of redundancy. So we're going for LRS or locally redundant storage. And let's click next for advanced. And the only change we need to make is to enable hierarchical namespace so that we get the data lake storage and 2. So let's check that. And we can keep everything as default. So I'm going to just click through networking, data protection, encryption, and tags. And let's click on review. And let's click create now. Okay, so the data lake has now been deployed. So let's click on go to resource to go to the data lake. So here we are in the storage account now, and we want to create a couple of containers. So what I want to do is I want to create a container called source and keep some data there and write a data factory pipeline to copy that data from source to the sync container. So in order to do that, we want to create 2 containers. That's what we're going to do. So let's click on the containers here and the data storage section, and let's click on plus a container here. And I'm going to create the 2 containers, one called source, and we can keep the public level access as private. And we want another one called sync. And as we said, we want to upload some data to our source container. So that's our source data. So let's click on source. In order to upload the files, you click on the upload button here and browse to the files. I'm going to use the population file that we used in the rest of the course. It doesn't matter which file we use for this exercise, but I'm going to go for the population by age.tsv file. And let's click open and then click on upload. So the file has now been uploaded. So we've got the data lake storage and the 2 containers, source and sync. Also, we've got the file in our source container. So that's all we need for this exercise. Let's now go ahead and do the same for our test and the production data lake storages. So I'm going to go ahead and create the test and the production data lake storages and also create the containers and upload the file. So let's do that. With that, we've now created all the 3 data lake storage accounts that we needed, and we've created the source and the sync containers in all of them, and also uploaded the population by age file to each of the source containers as well. So that's everything we wanted to do in this lesson. In the next lesson, I'll show you how to access the storage account from the data factory using managed identity. See you then. Welcome back. Let's now take a look at how to use system assigned managed identity as a solution for accessing data lake storage from ADF. Azure assigns a managed identity to each of the data factory resources when they are deployed. So we don't need to create them explicitly, and Azure takes care of that. As long as the managed identity has the required role assigned to the storage account, the data factory will be able to access the storage account. In this lesson, we'll grant the required access for the storage account to the managed identity of the data factory, and also we'll create a data factory pipeline to access this data, and we'll see what happens when it's deployed. Let's switch over to the Azure portal and get started. Here we are in the Azure portal, and this is our development resource group, which is dev.ci/cd demo.org. And as you can see, it contains the 2 resources that we've created so far. One is the data factory, and the other one is the storage account. Let me start by showing you the managed identity created by Azure, which is the system assigned managed identity on the data factory. So you can click on the data factory here, and if you go over to managed identities under settings, you will see the managed identity that's been created. As you can see, under system assigned managed identity, we've got an object, and the status is on. So that means there is a system assigned managed identity for this data factory, but we don't have a user assigned managed identity at the moment. So if you wanted to create one, you can do that. But as I said, by default, Azure creates a managed identity for each of the data factory resources, and that's what we're going to use. So the first thing we want to do is to provide access to the storage account for the managed identity. So in order to do that, you again come over to the resource group. I'm going to go into the storage account, and you go over to the access control and click on add, and click on add role assignment. The role that we're going to give is the storage blob data contributor. That role gives the data factory access to read and write data from the storage account. So that's what we're going to do. Storage blob data contributor. So let's pick that, and then let's click on next, and let's click on managed identity here under assign access to, and then let's click on select members, and under the managed identity drop down, select the data factory. So I've got 8 data factories, that's why I'm seeing 8 of them, but the one we're interested in is the dev.ci/cd demo area. So let's pick that, and let's click on select, and now let's click on next, and click on next, and let's click review plus assign to assign the role assignment. So that's what's happening. So it's added the role assignment here. So now our data factory has got access to this storage account via the system assigned managed identity. So that's one step out of the way. Let's now do the same for our test and production storage accounts so that the corresponding data factories have got access to the corresponding data lakes. As you can see, I'm now granting access to the test data lake to the test data factory. So let me click review plus assign. And now we are assigning the storage blob data contributor to our production data lake to the production data factory. So let me click review plus assign. And with that, we've granted all the accesses required for our data factories to the data lakes. That's the end of this lesson. I'll see you in the next one. Now that we've set up the data lake storage, let's start working on the data factory. So I'm going to create a feature branch and start working on that. The first thing I want to do is to create the link service. As you know, we have to access data from our data lake storage. In order to do that, we need to create a link service. So come over to the Manage Hub and click on Link Services and click New, and let's search for the data lake storage here. And we need the Gen 2 data lake storage, and let's click Continue. And I'm going to give it a meaningful name. I've called it as LS-CICD demo DL, which is the data lake name. And
ఏనాడే వద్దంటలే వాళ్ళనే వస్తారు నేను ఏ టైంగా తీసుకొచ్చారు.
I've suffixed it with managed identity because we're going to create another one for the access keys later on. So I just want to see the difference between the two. So this is called managed identity, and as we discussed, we're going to use the authentication type as managed identity, which is the system assigned managed identity. So let's pick that, and we need the subscription and the storage account name. So let's pick the subscription, which is my basic subscription, and we need the storage account name, which is the CICD demo DL in the dev environment. So that's dev CICD demo DL. So let's pick that, and as you can see, it's already listed the managed identity name, which is the dev CICD demo area, which is the same name as the data factory name, and we've already given access to the storage account for the managed identity. So we should be able to test the connection. So let's click on test connection, and I would expect it to be successful. So as you can see, the connection is successful. So it's as simple as that to create a link service. Let's click create. So now that's been successfully saved in our Git repository. Let's now switch over to Author and start creating the pipeline. And as we know, we want to create a pipeline to copy the population data. So I'm going to call it SPL copy population managed identity. And as we said, we simply need a copy activity. So let me bring in a copy activity, and I'm going to give it a meaningful name. And now we need to provide the source and the sync. We don't have a dataset, as you know, so let's click on new and create a new dataset. Our data source is again a data lake storage Gen 2, so let me pick that, and let me click continue. And as we know, we have a delimited text which is on TSV format or tab separated values. And let me click continue, and I'm going to give it a meaningful name. we are going to create separate datasets for our source and sync. As we know, we can't parameterize and have just only one dataset, but we're going to keep it simple and create separate datasets. So that's why I called mine as DS population source. And let's pick the link service that we just now created, and let's browse to the file, and that's under our source container, and that's called population by age.tsv. We can ignore the rest, and we don't need to import the schema because we're just simply trying to copy the file from one folder to the other. So I'm going to just click OK here. So the dataset's now created, and that's been assigned here as well, and we can leave the rest of the information as they are. And let's do a similar thing for our sync dataset. I'm going to click on new, and let me search for data lake storage gen 2, and click continue, delimited text again, and continue. And this time I'm going to call this one as DS population sync. And let me pick the link service, which is the same one, and this time I'm going to put the file in our sync container. So that's where it's going. Let's leave the file name as blank, and it'll use the same file name. And again, we don't want to import the schema, so let me click none, and let's click OK. And that's everything we wanted to do for the pipeline. So let me click debug, and we want to see that copying the file from our source to sync. And the pipeline has succeeded, and we should be able to see that it's copied one file from our source to the sync, and it's copied the same amount of data. But let's quickly go over to our storage account, make sure the file has been copied. And as you can see here, we've got the file in our sync container, and that's just been copied. Let me now save all the changes and merge the changes to our main branch by creating a pull request. So the pull request has now been created, and as you can see, we've got 4 new resources, and they are the link service pipeline and the 2 datasets. So I'm going to simply approve and merge the changes. And the merge has now completed, but as we know, it should trigger the build pipeline as well as the release pipeline. So let's see what's happening. So as you can see, the build pipeline is running, and let's wait for that to complete. So the build pipeline is now completed. Let's take a look at the release pipeline. So as you can see, it's now deploying to dev, and let's wait for that to complete for the test environment. Deployment to test has also now completed, so let's switch over to our test data factory and have a look at that. So I'm going to simply open up the test data factory. So here we are in our test data factory, and we've got the pipeline here, which is the PL copy managed population data. If I run this one, it's going to fail, and let me show you why. If we go over to our link services and click on the link services, it is pointing at our dev data lake. So we are in our test data factory, but we are pointing at the dev data lake. So the test data factory, as you know, doesn't have access to the dev data lake, so it will fail. First, it is incorrect that we are pointing at the dev data lake, and second, actually, it's also going to fail because we haven't granted access. So let me quickly test and show you. So I'm testing the connection here, and I've got connection failed. That's because we don't have the right access. So we need to change this. So when it's deployed, we need to change the URL for the data lake storage from dev CICD demo DL to test CICD demo DL. So that's what we'll do in the next lesson. But as you know, the release pipeline hasn't worked as we expected, so there is no point in deploying that to production. So I'm going to simply reject this approval. So let me do that. So I'm going to reject this. So we won't be deploying to production, but we'll fix that in the next release, and we'll deploy to both test and production. In this lesson, we're going to make changes to our release pipeline so that when the data factory pipelines are deployed to test and production environments, they are pointing at the corresponding data lake storages as well. So before we start making the changes, let's go over to our build pipeline and look at the ORM template so that we can see what needs to be changed. So let me go to the runs, and that's our latest run, and the artifact or the ORM template is here. So click on the published one here, and then there are the ORM templates. You can't really browse from here because we probably don't have the right access, but you can just simply download the artifact. So I'm going to click on download artifacts. And let me open the ORM templates, and that's where my ORM templates are. And I want to see the parameters file, so that's my ORM template parameters for factory. I'm going to open it in Visual Studio Code and show you the ORM template here. So as you can see here, we had the factory name, which is being hard-coded with the dev, which we've already overridden in our release pipeline. But we also now have this URL here, which is for the link service. So that's the one which has been hard-coded with the dev data lake storage name. We want to change that to test and prod respectively. So let's now go over to our release pipeline and make the corresponding changes. So I'm going back to my release pipeline. And let's click edit. So that will give us the pipeline in edit mode, and we want to override the parameter. So I'm going to simply go over to variables and add a new variable, and this time I'm going to call this one as data lake name. And let's provide the name of the dev data lake, and that should be scoped to our dev scope within our release pipeline. And let me add the other 2 as well for the test and the production data lakes. And now we've got the 3 variables for the dev, test, and prod. Let's go over to the pipeline. Let's start with overriding the parameters for our dev stage. I'm going over to tasks and go to ORM template deployment, and the override template parameters goes here. As you can see, we've already got the factory name, so we want to provide the link service connection here. So let me again go over to my ORM template and copy the name from here, and you want to copy it carefully so that you're not losing any of the parts there. And it has to be with a hyphen and then the name, and then you want to provide the value. So I'm going to simply copy the value from here, and then I'll change to replace with the variable name. So the variable that we created is the data lake name here, so I'm going to simply use that here. So that is $, and then you want to provide the variable name. So at runtime, the data lake name would be replaced with the variable value from the variable. So let me copy that, and I'm going to use the same in the other stages as well. So let me go back to the pipeline and switch to the test stage and make the change here. And also let's make the same change to production as well. So the changes have been completed, so let me click save. And let's create a new release and test the changes. So I'm going to click create here. And that's created the release 4, so let me go into that and see what's happening. I've got an error, so let's have a look at that. And the error is here. As you can see, we've got an empty parameter, which is not expected. I think that's because I made a mistake while adding the override parameters. So let's go over to the pipeline again, and let's take a look. So let me go to template deployment. And the problem is that I've added an empty line here, so that's probably caused the names to be blank. So let me just bring it over to the previous line. So I shouldn't have added a new line there. So just add a space and then add a new parameter, and that should make it work. So as you can see, so let me do the same change to the other stages as well. So everything looks okay. So let me save the changes. And let's create another release and test the changes, and hopefully it works this time. The changes to dev and test have completed, so let me click approve on production and we can have a look at the test data factory now. So let me cancel from this and let me refresh the data factory. And if I click on the link services, as you can see, we've got the test data lake in the URL. So it's pointing at the test data lake. So if I click test connection, it should succeed this time because this managed entity has access to the corresponding data lake. And let's click cancel and let's go over to the pipeline and click on debug just to make sure that it works okay as well. And the pipeline is completed, so let's go over to our data lake and take a look at that. So this is my test data lake, and under containers, under sync, we should see the file. So we are seeing the file. So it's been copied by our data factory pipeline. We should see similar results in our production as well, but let's ensure that the pipeline is completed. So this is the release pipeline that succeeded for the production stage. Let me go over to the production data factory. I'm just switching to the production data factory, and let's take a look at the link service to ensure that it is pointing at the right data lake. So if I go over to the link service, as you can see, it's pointing at the production data lake, and the test connection would be successful as well. So that's brilliant. I'm going to test this pipeline. I would encourage you to test it and see that the copy activity has done what it's supposed to do. So that's the end of this lesson. I'll see you in the next one. In this lesson, we're going to talk about the approach of using access keys to authenticate to the data lake. There are two approaches you can follow. Let me talk you through both approaches here, and then I'll recommend the one I think is better and the reasons for it. In the first approach, we store the keys in the data factory link service itself. As you can imagine, storing the keys in Git is not a good idea. So data factory won't store the keys in Git. Instead, it auto-publishes the change and stores the keys in data factory repository, and the values in the Git repository will be stored as blank. Which is great. We haven't exposed any keys, and the keys are stored in the data factory. So everything in the development data factory will work as expected. But when we release the changes to test and prod, the keys will be carried over as blank values because that is what is in Git as well as in the ARM templates. To rectify this problem, what we can do is store the keys in each of the environments in a key vault and ask the release pipeline to read the keys from the key vault and override the ARM template parameters with the actual keys. So when a deployment happens, the keys will be updated in the data factory with the actual values and everything works fine. There are a couple of issues with this approach. Firstly, I don't like the fact that the dev data factory carries out an auto-publish of the link service, which can put the code in the data factory out of sync with what is in Git. But we can live with this. The main issue here is that we are relying on the release pipeline to update the keys to the test and the production data factories. It's common practice in the industry to rotate the keys of any data lake every few weeks to ensure that the keys are not compromised. Once we rotate the keys, in order for the keys to be updated in the data factories, we not only need to update the key vault, we also need to do a deployment so that the keys are updated in the test and the production data factories. This can cause unexpected issues, and also it is an unnecessary deployment. The better option is to get data factory to get the keys from the key vault every time it needs, rather than storing the keys in the data factory itself. With this approach, we just need to update the key vault whenever the keys have been rotated, and data factory will get the new keys from the key vault at runtime. With this approach, we can avoid both the auto-publish of the changes as well as the additional deployments. So I would recommend using this approach, and this is what we're going to do in the next few lessons. Now that we understand the solution using access keys, let's look at the additional resources that we need in order to implement the solution. As you can see, we need 3 new key vaults, 1 per environment. Let's look at the names that we want to use for these key vaults. Again, I'm going to keep the names of the key vaults consistent with the other resources. Also, I'll create them in the resource group that we use for the data factories and the data lakes. Let's switch over to the Azure portal and start creating the key vaults and set up access. Here we are in the Azure portal. Let's click on create a resource and search for key vault. And let's click create here, and let's pick the subscription, which is my pay-as-you-go subscription. And as we said, we're going to use the same resource groups, which is my dev CI/CD demo RG for my dev key vault. And we want to give the name for the key vault. So I'm going to go for dev CI/CD demo KB. And I'm going to pick my closest region, which will be UK South, and I'm going to keep the pricing tier as standard, and you can leave the others as default. So let me click on Review Plus Create, and let's click Create now. So that key vault's now been deployed, so let's go over to the key vault. The first thing we want to do is to give access. So we want the data factory to be able to access this key vault. So in order to do that, you go to Access Policies. So that's the menu you're seeing here on the left-hand side. So let's click on Access Policies. As you can see, my user itself has got the right access, but the data factory needs access. So in order to do that, click on Create. And the permissions we need for our exercise are get and list permissions on secrets, because we are going to save some secrets here, and the data factory needs to have the get and the list permissions. So that's what I'm selecting here. So these two here in the middle under secret permissions, and let's click Next. And now we need to select our data factory. So let's search for our data factory name. So that is the dev CI/CD demo ADF. So we are giving access to the data factory. And let's click Next. And again, let's click Next and click Create. So now we got our data factory, which has got get and list permissions on our secrets. So now that we've given the permissions, the next thing we want to do is to create the secrets. So in order to create the secrets, you come over to Secrets menu under Objects section here, and then you can click on Generate or Import, and we need to give a name for our secret. So let's give a meaningful name. We shouldn't be using any environment-specific names here, because it is going to be the same name we are going to use within every key vault. So depending on which key vault we are pointing at, data factory will know which key to uptime. You'll understand this later on, but please don't put dev or test or prod here. Just give a meaningful name. So I'm going to go with the name of the storage account, and then I'm going to use the word key here. So that'll be CI/CD demo DL key. And that's the name for my key, and we want the value. So let's go and get the secret value, which is our access key. So I'm going to go to Azure portal and obtain that. So I want the key for my dev storage account. So I'm here on my dev data lake storage account, and let me get the keys. So in order to get the keys, you come over to access keys under security and networking, and then you can show the key. So you can pick the key 1 or key 2 depending on your security policy. So I'm going to click on show key here, and let me copy that. And that key has now been copied. I'm going to go over to my key vault and paste it here. So that's the key we wanted to paste, and you can give a content type here. So I'm going to say this is my access key. This is optional. You can leave that if you didn't want to give it. And let's click create. So that'll create the secret for us within our dev key vault. So let's now do the same for our test and production key vaults. So remember that we've got three things to do. Firstly, we need to create the key vault, and then we need to add the access policy so that the data factory has got access, and then we need to add the secret. So I'm going to do that for my test and production key vaults now. So the test key vault is now created, but we need to provide access. So remember that you want to give the get and list permissions, but you want to give those permissions to your test data factory. So make sure you're selecting the test data factory here, and let's click next. And that access policy has now been created, and I'm simply going to add the secret. Again, remember, you're going to use the same name that we used previously, which is CICD demo DL-key. You may have used a different name, but use that name, but don't give any environment specific values here, and we want to get the secret value. So I'm going to get the secret value from my test data lake. So that's what I'm going to do from here. So that's been created as well. Now you know what you're doing, so I'm simply going to do the same for production. So that's all been done. This is everything we wanted to do in this lesson. I'll see you in the next one. Now that we've created the key vaults with this, as well as we've given the access, let's start creating the pipeline by creating a feature branch. So let's do that. And as we did before, let's start creating the link service. So I'm going to pick my data lake storage, and let's click continue, and I'm going to stick to the same naming standards I used before. And as we discussed, actually the authentication type is account key, but this is where the difference is. Instead of picking the account selection from the subscription, we're going to enter it manually. So that's when you get the option to pick the keys from Azure Key Vault. So we need to provide the URL of our storage account. So you can get that from going to the storage account here, and let's look at the endpoint. So that's where you'll get the endpoint for the data lake storage. So that's here, so that's your endpoint here. So let me copy that, and let's go back and paste it here. So that's our data lake storage endpoint. And now we don't want to provide the storage account key here. We want to pick it from the Key Vault. So in order to do that, you click on the Azure Key Vault, but we need a link service to the Azure Key Vault so that data factory can access that. That's going to be called ls_, and I'm going to give the name of the key vault. And let's pick the subscription. So that is our pay-as-you-go subscription, and we want the key vault name. So we've got quite a few key vaults here, but the ones we created for this project are dev, CICD demo, and the test and the prod. So the one we need is dev here, and we want to authenticate. So we, as you know, we use the managed identity to authenticate. So we're going to use the same here, and let's test the connection here. So I'm going to click test connection, and the connection is successful. So we now have a new link service which gives us access to the key vault. So that's what we pick here, and we need to provide the secret name so that we can get the key from the key vault. So we got only one secret. That's the secret name we gave, which is CICD demo DL-key. So let me pick that, and we can get the latest version of the secret value from there. So that's everything done. So if I click test, what's going to happen is data factory is going to go over to the key vault, get the value of the secret, and then use that to authenticate access to the storage account here. So let's try that, test connection, and that should be successful. That is successful. As you can understand, it's going a couple of levels, but data factory takes care of everything. It basically goes and gets the secret values and uses that to authenticate to the storage account. So let's click create. Now that the difficult things out of the way, let's go ahead and create the pipeline. So I'm going to go to the author tab and then click on new pipeline to create the pipeline. And as you know, we need the copy activity, so I'm going to just bring that over here. And we need a source and a sink. We don't want to use the same source we used previously because we know that's using a different link service, which is using the managed identity. But here we are trying to prove that we can use the access keys to access the dataset. So we're going to create new datasets here. So I'm going to click new and search for data lake again. And that's a delimited text, and let's give it a name. But this time I'm going to suffix it with access keys, so we know that it is a different dataset using the access keys. And let's pick the link service, which is the ls CICD demo DL access keys. And I'm going to browse to the file which is under source, and that is the population by age.tsv. And let's click OK. And again, we don't want to import the schema, and let's click create. So the source has now been created, and let's create the sync dataset as well. And again, I'm going to do the same thing. And this time we just want to give the folder where we want the file to be landed, and that is our sync folder. And I'm going to click OK. And again, we don't want to import the schema, so let me click OK. And that's everything we wanted to do. So we basically have a pipeline which has a source and a sync, but both datasets are using a link service which is accessing our storage account via the access keys. So let me quickly do a save all, and I'll debug the changes and show you that the changes have worked. So as you can see, the pipeline succeeded, and it's copied the file from our source to sync. And if you go over to your storage account, you will be able to see that as well. And that's our sync, and the file's just been copied at 11:19 a.m. as you can see here. Let me go over to the data factory and create a pull request to merge the changes. So the changes are merged now, and we should be able to see the build pipelines running, and then that'll be followed by the release pipeline. The release pipeline has now completed deploying to the test environment, so let's take a look at the test. It's running, and then that'll be followed by the release pipeline. The release pipeline has now completed deploying to the test environment, so let's take a look at the test data factory. So I'm here in the test data factory. Let me do a refresh, and we've got an extra pipeline here, but let's take a look at the link services. So as you know, we've got the 3 link services now, but let's take a look at the key vault one. As you can see here, we are in the test data factory, but it is pointing to the dev key vault. This is something we need to change so that the link service in our test data factory is pointing at the test key vault. Otherwise, things won't work. So the changes we need for that are very similar to what we did for our data factory name and the storage account name. So we just have to change our ORM template parameter to override with a new value. So that's what we're going to be doing in the next lesson. But I would encourage you to have a go at it yourself, and if you get stuck, please come back to the next.
Pipeline.
Welcome back. before we start making the changes to our release pipeline, let's take a look at the ARM template parameters so that we know which parameters we need to override. So let me go over to the build pipeline. So here I am in the build pipeline. Let's go over to the latest one, and we want to download the artifact from here. So I'm going to do that. And let me open up the ARM template parameters in Visual Studio Code again, and we'll take a look at the parameters. As you can see here, we've gone from 2 parameters to 4. The 2 new ones are here. The first one is the parameter pointing at the key vault. We know that we need to change that one. We discussed that in the previous lesson. We also have another parameter for the dead link. As you know, we created another link service to access via the access key instead of using the old one, which was the managed identity. That's why we've got 2 parameters both pointing at the dead link. So we now know that we need to make changes to the release pipeline to override these 2 parameters, and also we need a new variable to keep hold of our key vault name. So I'm just copying the name of the key vault here, and let's go over to our release pipeline. So I'm going to click on releases and then click edit here. So that opens up the release pipeline here. And let me go over to variables, and we want to add a new variable. So I'm going to call this as key vault name, and that's my dev key vault name. So I'm going to assign it to the dev scope, and I'm going to add 2 new ones for test and prod as well. That's all done. We've got the 3 new variables. Let's go back to the pipeline and click on tasks and go to ARM template deployment, and we need to add the 2 new parameters here. So let me copy the name of the parameters. So I'm back in my Visual Studio Code. I'm going to copy the name here, and that's the name of this parameter. So that'll go as hyphen and then the name of the parameter, and then you want a blank space, and then you want to put the values within double quotes here. So I'm going to copy the entire value, and then I'll replace the key vault name. So we want to change the key vault name to use the variable name. So that'll be $, and then the name of the key vault. So I think I call that as key vault name. And that's one parameter done. We want the other parameter, which is the link service for the storage account with the access keys. So let me copy that as well. And for this one, we can copy and use the value that we already have for the managed identity. So that will be this. So that's done as well. So we have now got the 4 parameters. So you can click on the 3 dots here to see them. As you can see, we've got the 4 parameters and the values here. So let me copy this, and we can use this value in the other 2 ARM template deployments as well. So I'm going to go over to test and just simply paste what I got here. And also let me do the same for the production stage as well. So I'm going to do that here. And that's everything we wanted to do. So let me click save. And let's create a new release to test our changes. So that's release 7, and let's wait for the changes to be deployed. The deployment to dev and test have now completed. I'm going to simply approve the changes for the prod as well. But let's take a look at the test data factory to ensure that the changes have come into effect. So let me click refresh, and let's take a look at the link service for our key vault. And as you can see, we're now pointing at the test key vault, and test connection should be successful as well. And similarly, when we look at the access keys link service, that should also be pointing at the test data lake storage, and test connection should hopefully be successful, and it is. So the changes have worked. In order to ensure that everything's worked as we expect to, let's debug the pipeline. So we want to debug the pipeline, which is the copy population access keys, and we are in the test data factory. So it should pick the data from our test source container to test sync container. Before we do that, I'm going to simply go into the sync container and delete the file so we can ensure that the copy happened as a result of the changes we've just done. So I'm going to simply delete the blob, and that's now disappeared. And let's go over to the test data factory and debug the changes. So the pipeline execution has now succeeded. So let's go over to the test data lake storage and refresh the contents within our sync container. And as you can see, we've got the new file here, population by age.tsv, copied just now at 11:44. So succeeded. So let's go over to the test data lake storage and refresh the contents within our sync container. And as you can see, we've got the new file here, population by age.tsv, copied just now at 11:44. So as we can see, the changes have worked, and the deployment to production has succeeded as well. I'm not going to test the changes within production data factory, but I would encourage you to go and do that. But in summary, in the past few lessons, we've learned how to use access keys as well as managed identity to access storage resources within Azure, and also we've learned how to override parameters within the pipeline as well as using key vaults. So these learnings should give you enough knowledge to be able to cope with other storage solutions, for example, using Azure SQL database, and also using other compute engines such as Databricks or HDFS Insights. And that's the end of this lesson. Thanks for listening.